Check. Hello? Alright. My game PC not say. Oh, there's no sound here.
So, why?
Got it. Hey, hello. What's up? What's up? How you guys doing? I really don't understand this problem. Yeah, I was muted. Thanks for letting me know. This question is crazy. So, okay, I guess, I don't know. I feel like we just have to go through the code, right? So we start small, large, whatever, I guess. Delayed is the dictionary, I guess. That's what they call it. Create a function, which I don't know if we need to. So basically, for I in range, nums is equal to nums of I. How do we, if not small or, I don't get it. How do we know if we need to add to the large or the min or max heap? This is the core question. You always compare the new number with the top. If max heap is empty or num is less than, because we want to split the window into two halves. The left side stores the smaller half, the right side stores the. I see. Okay, so the point of the heap is to keep track of both sides. What's up, C? I see. So the point is that we have both sides. So I guess what this question is saying is that if we're given this array and our window is size k, so our first window is this, our max heap would be the left, numbers on the left, and then min heap numbers on the right. Because if we do it this way, yeah, that makes sense. Basically, like, visually what we're trying to do is, like, we have a split. So min heap, it's like max heap, it's like median, basically. Min heap, it's like the format. Because what a max heap is going to do is it's going to order it from greatest to smallest. I feel like visually it's not like intuitive because I think about things from left to right. But I mean, I guess you're supposed to just know the max heap applies to the left side and the min heap because you want the smallest number of the right side, right? Because we're looking for the median. And the min heap gives us the smallest on the right side, while the max heap gives us the largest on the left side. It's kind of like, I guess, the whole reasoning of this problem. Whether it's like, dude, I don't know anyone that would be able to figure this out on an interview setting. If you've never seen this question before, this is insane. The Prasanna. Okay, so that makes sense. So let's, I guess. Okay, now the question becomes, how do we know that which side gets the middle number, right? Which side gets the middle number and why? Stores the lower half of the numbers and stores the right half. If the new number has less than or equal to, it belongs to the left side, otherwise it goes to the right. So if there's an odd number for the window, does the min heap get the extra number, or max heap, or both? The max heap stores the smaller half. The right half stores the larger half. When k is odd, and the median is just that middle number, so we always make sure that the max heap has one more element than the min heap. We always make sure that the max heap does it matter though? Does it matter if we had the max heap store the extra value or the min heap? It does matter. Oh, I see. Okay, so it doesn't matter which side you use, but okay, standard convention is we can have the max heap on the left side store the extra element if k is odd. This makes it easy to define. Median is negative max heap of 0. Otherwise, median is negative max heap of 0 plus. Give us a link to the problem. It's called, you can just search it up. It's number 480 on Leetcode. Sliding window median. You just type that up. Unfortunately, I don't have the YouTube chat on the same PC, so it's not as simple. And I'm a little bit lazy. Okay, sure. Let's say, okay, like it doesn't matter which side, but let's say the left side holds the extra element. So in that case, if we decided that the left side has one more element, then this would look like 1, 3 would be the max heap. Oh no, sorry. It would be -1, 1. And then the min heap would hold 3. That's what it would look like on the first run. And then basically, because this is a max heap, we can literally pop it, right? Because the window size is always is odd. So we can always just pop from the max heap. Thank you, Hilo. I don't know. I still feel like I'm trash, but to be fair, I mean, these questions are harder, and I would say the solutions are becoming more complex. So, you know, I do feel like, you know, foundationally, I am starting to like have a decent grasp on certain data structures. I still feel like I still need to learn a lot more, but as long as I'm getting better, I guess that's all that matters. I don't know. A part of me though feels like some of this is just like Like, I swear, if you got this question in an interview and you've never seen it before, like, it's over. If they're expecting you to solve it, like, with the optimal solution. Because, like, solving it, you know, if it's sorted, it's not that bad of a problem. But because it's not sorted, it's like, this question is just crazy. This question is crazy. Okay, so this makes sense so far. I'm understanding it finally now. I literally have been looking at this problem for like 2 days, I feel like. Okay. So this is fine. All right. So now how does it, okay, now explain the balancing part. Okay. Okay. I get splitting the heaps 2 and having the max heap for the left side to have the extra element if it's odd. Now, can you explain the rebalancing part? At any point in time, if the max heap is equal to the min heap, okay, yes, if it's even, then they should be equal. Or if it's odd, then the min heap plus 1 is equal to max. Yeah, so like in this case, yeah. It's either one of these two cases, right? So this ensures max heap root will always give the medium when k is odd. There's still people like him who have the courage to come live and do something that's super crazy, and look, just 3 people are watching. Come live. What do you mean? Yeah, I don't even think I'm doing anything that's crazy. I'm literally just, I'm going live, literally just studying. That's it. I don't think it's that crazy if I'm being honest. The average of both roots gives median when k is even. Yes, this makes sense. So then when do you rebalance? When you, wait a minute. Oh. Yeah, hello. I mean, I'm just doing my best. As long as I feel like I did my best, then I just need to show up like almost every day. That's it. I need to show up every day and lock in, which I need to make sure I just don't get distracted when I'm trying to lock in. If the length of the max heap is greater than, yeah, we just pop it, right? We just pop the max heap. So let's say, well, that's the thing. If we go to the right, we pop the left side, right? Let me think about it. So this is the first heap setup, right? So the next time we actually have to pop the 1. Oh, wait. But how do we know it's the 1 though? And how do we know what to pop in and out? Oh, we compare it based on the number. Got it. Yeah, because if we got a new number, right, we check. Okay. So I think the answer is based off the fact that you have too many in the max heap. Okay, so when do we know though? When do we know when to add to the min heap or the max heap? It's I think it's just based off comparing. If it's not a max heap or none, so by default, are we just, if the number is less than or equal to the max heap, then it goes to the max heap. Yes, if it's larger, then it goes to the right, which makes sense. Sense. Okay. This question is making sense. All right. I just pray to God that the amount of difficult problems like this one doesn't exist. Like, I hope there's not that many. I mean, after this question, it's a bunch of mediums again. And then a few hards. Oh my God. I don't know how many I should do and then like just stop and just memorize them. Because I also do have to study for systems design. It's over. Okay. Okay, now that I understand like the process a bit better, I feel like watching this video will help. So I think the thing that I was confused about was the fact that like this, like, I understand that we have to use the heaps, but I didn't really truly understand what the heaps were actually doing. Now that I understand that, so I guess just thinking about it, you know, what a heap actually does, a max heap will, you know, basically allow you to access the largest element at any given point from a heap hop. And it'll also order the items in a way that's efficient. It's in log k time. And so what we want to do is we want to have the max heap on the left side, because that way we're technically, it's not like I feel as intuitive if you were to figure this out on yourself. But like, let's say you had a 1, 3, and -1 in a max heap, or yeah, in a max heap case, you'd, if you were to just reorder this whole thing, it'd be 3, 1, -1. But like, you know, from this perspective of, we want to have the number that's the median value, you can access that through a max heap on the left and then a min heap on the right. I guess that makes sense, because on the right side you want the smallest element and on the left side you want the biggest element, because that is the way you find the median, assuming that you split in half. Okay, that all makes sense. That all makes sense.
And we'll also keep a dictionary which keeps track of the elements that we need to get rid of the heap, but we're only going to do this for the purpose of efficiency when that element actually either gets to the top of the max heap or the top of the min heap. And remember, this is because popping from the top of a heap is a constant space thing. We don't need to basically reorganize the heap after that. So that is the reason we're going to do that. Okay, so that is kind of the intuition here. Let's now actually go into the code editor and type this one up. It's a bit verbose, but the logic is pretty straightforward. I'll walk you through it line by line as we always do, and hopefully everything will make sense once we do that. Okay, cool. Let's go code it up. Let's now code this up. Remember that to do this problem, we're going to need a max heap, a min heap, and also a dictionary to keep track of what elements are in the heap, which we might need to remove later, or well, we will need to remove them later. So let's define those data structures. So the first one is going to be the max heap, going to be an empty list. The next one is going to be a min heap, also going to be an empty list. We now need
This may be the last ad you'll ever see.
This may be the last ad you'll ever see.
that dictionary, which is going to keep track of the count for each of the elements that are in our heaps. So we're going to say the heap dictionary is going to be, let's see, collections.default dict and int, because we're storing a count. Okay, we also need a result array to store our result. Now the first thing that we need to do is, if you remember, we need to basically handle the case of the first k elements. In this case, you know, we're not removing anything, we're not adding anything.
Handle the first case. Okay, that's not too bad, right? The initial state.
So we need to populate our heaps for the first k elements, but we also want to make sure the heaps are populated correctly, so that way when we do the rest of the elements, they are, you know, correctly set up. And remember, to refresh our memory, the max heap is going to store the values to the left of the median, and the min heap will store the values to the right of the median. And we have said, in the case that there's an odd amount of k, then the max heap will be allowed at most to have one more element than the min heap, and that's how we're going to deal with the odd case. So let's now populate the heap, so the first k elements. So we're going to say for I in range k. What we're going to do is we're basically going to populate the heap. So we're always just going to assume that we can put it onto the max heap, and then we will take whatever is in the max heap that needs to go into the min heap, and actually check whether or not we're balanced after that. And if we have to fix the balance, then we will. So what we're going to do is we're going to say heap q dot heap push onto the max heap. And remember that in Python, a heap by default is a min heap, so to get max heap, we'll use negative numbers. So we're going to use negative nums of I. Now that we've added something to the max heap,
We're adding to the max heap.
potentially we need to
For size k.
move something over to the min heap. So we're
Yeah, that's right.
going to do that operation as well. So we're going to say heap q dot heap push, and we're going to add to the min heap the value from the max heap that actually would now need to move over because of the median. Now we're not actually going to calculate the median yet because we don't have k elements, but we're just going to assume that when you move one, when you add something to the max heap, then something needs to get added to the min heap.
Why is he saying that? That doesn't make sense. Why is it why is it when you add to the max, the min has to move?
to kind of keep them in check. So basically take the min heap, and we want to just take whatever is at the top of the max heap. So basically that element that's closest to the median, we're going to move it to the max heap, and then we'll account for the fact that we may have moved something that we didn't want to move momentarily. So we're going to say heap q dot heap pop. So we're going to pop in the top of the max heap. Remember, we need to nullify it because we put it in negative. Now we need to flip it back to a positive because the min heap is going to operate as a normal min heap. Now what we want to do is we actually need to check whether or not the min heap has more elements than the max heap, right? When we accidentally popped from the max heap, we actually might have more elements in our min heap, which isn't allowed, right? We said that the max heap should either have the same amount of elements in the min heap. That's how we're going to deal with refresh our memory. The max heap is going to store the values to the left of the median, and the min heap will store the values to the right of the median. And we have said, in the case that there's an odd amount of k, then the max heap will be allowed at most to have one more element than the min heap. And that's how we're going to deal with the odd case. So let's now populate the heaps with the first k elements. So we're going to say for I in range k. What we're going to do is we're basically going to populate the heap. So we're always just going to assume that we can put it onto the max heap, and then we will take whatever is in the max heap.
Oh, you just put it in the max heap and then you just basically funnel it into the min heap? Is that the intuition? Is that what the balancing part is? How do you initialize the heaps? How do we know which heap it goes into? I mean, I didn't mean it like that. If not max heap or num is less than the max heap. I see. So you can, okay, wait. All right. So our decision is if it's not a max heap or the num is less than or equal to. If this is basically just saying if it belongs to the right side, put it in the right side, right? If our number is greater than, then we go here. But so then wouldn't you have like 10 elements greater than the max heap? So wouldn't there be like 9, 10 elements on the max, on the min heap, and only 1 on the max heap? You rebalance after every insertion to enforce size limits, so that never happens. After every insert you run, if the length... Oh. I think that makes sense. Okay.
Heap that needs to go into the min heap and actually check whether or not we're balanced after that. And if we have to fix the balance, then we will. So what we're going to do is we're going to say heap q dot heap push onto the max heap. And remember that in Python, a heap by default is a min heap, so if you have max heap, we'll use negative numbers. So we're going to use negative nums of I. Now that we've added something to the max heap, potentially we need to move something over to the min heap. So we're going to do that operation as well. So we're going to say heap q dot heap push, and we're going to add to the min heap the value from the max heap that actually would now need to move over because of the median. Now we're not actually going to calculate the median yet because we don't have k elements. But we're just going to assume that when you move one and you add something to the max heap, then something needs to get added to the min heap to kind of keep them in check. So we basically take the min heap and we want to just take whatever is at the top of the max heap. So,
oh, yeah. I see what's happening. So like, think what ends up happening is like you add one here, and then this will pop to the min heap. So then the min heap would have one, right? I don't know. This makes no freaking sense.
Basically that element that's closest to the median, we're going to move it to the max heap, and then we'll account for the fact that we may have moved something that we didn't want to move momentarily. So we're going to say heap q dot heap pop. So we're going to pop from the top of the max heap. Remember, we need to nullify it because we put it in negative, and now we need to flip it back to positive because the min heap is going to operate as a normal min heap. Now what we want to do is we actually need to check whether or not the min heap has more elements than the max heap, right? When we accidentally popped from the max heap, we actually might have more elements in our min heap, which isn't allowed, right? We said that the max heap should either have the same amount of elements in the min heap, or it can have one more. If the min heap actually has more elements, then this statement which we did was we shouldn't have done that. So the way we're going to account for that is we're going to say that if the length of the min heap is actually greater than the length of the max heap, then what we want to do in this situation is actually get rid of an element from the min heap and add it back to the max heap. So that way our heap invariant is maintained. So we're going to say heap q dot heap push. We're going to push onto the max heap. We're going to push on heap pop. Heap q dot heap pop onto the min heap, right? So we take a positive element, the smallest element of the min heap, pop it, and then add the negative because remember the max heap needs to use negative numbers. Okay, so at this point we basically have our first k elements. Now at this point we need to calculate the median. So what we're going to do is we're going to say if k is actually odd, then we need to basically take whatever's at the top of the max heap. And the reason that we allow the max heap to actually have one more element of the min heap is that in the case that k is odd, then we just need to take whatever's at the top of the max heap because that will be the median in our case. So in the case that k is odd, the item at the top of the max heap will actually be the median itself. If it's even, then we just need to take the top of the max heap, the top of the min heap, add them together, and then divide by 2. So we're going to check if k is actually odd. Then all we need to do is say results.append. What we want to take the minus of whatever's at the top of the max heap. Again, remember the max heap is storing negative elements here, so we just need to flip the sign. And then we take whatever's at the top there, because that is the median in the case that we have an odd amount. Otherwise, if it's even, then we need to do some math here. So we're going to say res.append. What are we going to append? So we're going to say minus the max heap, so whatever's at the top of the max heap, plus whatever's at the top of the min heap. Min heap of 0, and then we need to just divide this by 2, and that is our median. So pretty straightforward. That's how you calculate a median mathematically. Okay, now we processed the first k elements. We calculated our first median. Now we need to basically do this for the rest of the medians. So we want to basically just move our sliding window up by 1 each time. Now this is where this problem gets tricky. I think there's two hard parts of this question. Understanding how to set up the heap in the beginning. This part is easier. And then now what's going to happen is we have to actually sort out how to add an element and remove an element, and basically keep track of what to do with our heaps. So pay attention because this is the tricky part. I'll do my best to explain. So we're going to say
Let me ask ChatGPT if the solution is not bad or if it's bad. I'm watching someone solve this and they're doing it like this. Is this the optimal way to do it? I didn't even post the picture. Okay, I mean, I guess I'll show the whole solution.
based on how the previous is, and we are done. Now, tricky part. Did I make a mistake coding this up? I would say yes. Yeah, so I'll just, okay, variable median equals to that.
He does write the whole thing though. Yo, this is like 50 lines of code. Are you kidding me?
What we want to take the minus of whatever's at the top of the max heap. Again, remember the max heap is storing negative elements here, so we just need to flip the sign. Then we need to basically take whatever's at the top of the max heap. And the reason that we allow the max heap to actually have one more element of the min heap is that in the case that k is odd, then we just need to take whatever's at the top of the max heap because that will be the median in our case. So in the case that k is odd, the item at the top of the max heap will actually be the median itself. If it's even, then we just need to take the top of the max heap, the top of the min heap, add them together, and then divide by 2. So we're going to check if k is actually odd, then window, but we also need to remove the 1 because we always slide it over by 1, so divide by 2. So right when we accidentally pop, it actually has 1.
So the solution so far is optimal. Is this how he wrote it too? Part of the code builds the initial window. So when we initialize, we just push to the max heap, left heap, and then immediately pop it to the right heap to assume best balance. This is clever, apparently. Store the negated value, immediately pop, push into min heap. So ensures all elements in max heap are less than or equal to all elements. Wait a minute. Wait, so doesn't this mean by the end of the for loop, there won't be in anything in the max heap? Wait a minute. Okay, so but before the balancing it is empty, no? Interesting. So so visually we have array, right, of nums. We have the median, and this is our max heap. This is our min heap. So this guy, bigger. I need a bigger eraser. So if we had -1, -1, 3, push it to the max heap, then goes immediately to the min heap. So by the end of all of this, what would this look like? So what would the result look like by the end before rebalancing? An ordered list from smallest to largest. No? Okay, 153. Max heap. Pop -1, push 1 to min heap. Okay. Rebalance, move 1 back to max heap. Wait a minute, what?
More elements, then into the min heap, right? So we take a put the max heap at the top of the median. So then this statement which we did was our first k element. Heap q dot heap push.
Oh, we're doing it all at the same time. I don't understand why we do this though. I feel like I'm trying to figure out why this works or how you would figure this out, but I don't think there is a way to figure it out. I think it's just clever. Wait a minute. Oh, I see. Okay, so I'm reading this wrong. So we max heap the 1, right? We insert the 1, max heap. Then it goes to the min heap. Max heap is now nothing. Then we rebalance, right? But how do we know to rebalance? It's because we have nothing, right? If we have nothing.
Push.
If the length of the min heap is greater than the max heap. So if the right is bigger than the left, then pop whatever's on the right and move to the left.
We're going to push onto the max heap. We're going to push on heap pop, heap q dot heap pop onto the min heap, right? So we take a positive element, the smallest element in the min heap, pop it, and then add the negative, because remember the max heap needs to use negative numbers. Okay, so at this point we basically have our first k element. Now at this point we need to calculate the median. So what we're going to do is we're going to say if k is actually odd.
Okay, this makes sense. Okay, let's kind of just code some of it, because I think I'm starting to understand it. All right, so we need 2 heaps plus a dictionary. So we have the min heap, max heap, and then a dictionary for I in range of k. So like we said, going to heap q dot heap push, and then like we said, max heap, median, min heap. This is kind of our structure that we have to remember. And then of course we have to keep in track of max heaps, negative values to maintain this. So we're gonna heap push to the left side first, right? So max heap, and we're going to do negative num sub I, right? Gonna push that, and then right after that, going to heap push and what? Okay, I mean, I'll probably figure out why this works soon, but negative heap q dot heap pop of max heap, right? So this will give, let's print the max heap. Nothing for I in range k. What is k? K is 3. Is this not right? Oh, I should be printing the min heap, I feel like. Yeah, max heap has nothing. Right? Yes. So this min heap. So the thing is, like, so we start with the 1, right? We add the 1 to the min heap. Oh. I see. Okay. So then we have to check, right? Is the length of, if the length of the right side, which is the min heap, right? So if it's greater than the length of max heap, then we have to move dot heap push to the max heap, which is on the left. Then we store negative heap q dot heap pop from the min heap, right? Else the other way around, I guess. Heap push. Is this even possible? Min heap, I'm assuming it's possible. So now we have it balanced, I think. So now it's just 1, 3. And then the left side is -1. How the hell does this work? This is crazy. Okay, so we start with the first number, right? The first number goes into the max heap, which is the left side. Goes in -1. We push it. And if the length of the min heap is greater than the max heap, so actually in the first step, I guess let's see the ChatGPT. So actually in the first step, yeah, this moves back to the max heap. So this first one stays in the max heap. And then we insert the 5, right? So we insert the 5. So it's -5 and -1. And actually -5 is, or 5 is the biggest. We actually push it to the min heap. I don't know. I just don't know how you're supposed to know this works. That's the thing I'm struggling with. Like, I feel like what I'm reading makes sense, but in what world am I supposed to figure this out without looking at the solution? Okay, I mean, I guess you're just supposed to know, like, there's a pattern, I guess. Sure. How to maintain median access. So then do I just memorize it? I mean, I guess I can just understand it. Handle the balancing logic. So then is this part, so then okay, so why does it work? So how does pushing to the max heap then popping to the min heap work? then rebalancing after. How does it all end up sorting correctly? If we always push into the max heap, pop into the min heap, and then maybe rebalance, how does this process actually sort? Okay, so the max heap will have the smaller half of the numbers. And the min heap, yeah, I get that. Let's run through an example. Okay, so we max heap the 1, pop it, push it to the min heap, but the rebalance says if the min heap is greater than the max heap, then add it to the max heap. So boom, so it's in the max heap now. Okay, next, then it's 3. So the max heap now has 3 and 1, so we pop the 3. Oh my god, it's because it's the biggest. Oh my god, it's oh, I see, it's because, oh, I see. Oh, so this works because the max heap, because when we push the new elements to the max heap, we'll always push the largest element to the min heap. Is that why this works? Oh my god. That's so clever. That's clever, but like, oh my, like, it makes sense. It makes sense. So we're always pushing a new number into the max heap and then moving the largest of the left half to the min heap. So then the max heap only contains the smaller stuff. We always insert the max heap and then just, oh my god. No, that's smart, no? Looks like a variation of sliding window maximum. Could be, but this one's sliding window median. Sliding window median. I see. Okay. Is this like... Okay, so is this a common pattern that people use? People use to solve questions like this? Should I just memorize this? Or are there other ways to balance? Yeah, I can't memorize it blindly. It's never good to memorize blindly. For median tracking, not really. Okay, that makes sense. Alright. Okay. Okay, so the reason this trick works is because the max heap will always have the largest number. And we immediately just push it to the min heap. This is so clever though. I don't care. I'm just gonna like memorize that this is supposed to be the way it's done. But like there's no way to like know that this would work. How the hell? That's so clever. That's genius. So you heap q dot heap push, right? And then, so I guess there's cases where you can have a lot more of the... How can it ever hit this else case?
Then...
Oh yeah, we don't need it, which makes sense because it will never hit this else case. This makes no sense. This was troll. This is like impossible because, and it makes sense because the reasoning is that we're always pushing to the min heap. We're like never really pushing at this part to the max heap. So there's never really an else case. It's only going to be possible that the min heap is going to be bigger, and if the min heap is bigger, then we rebalance it. So rebalance after adding to min heap. And then let me just write a comment here. Pushing to max heap first ensures we always push the largest element to the min heap. So clever, but like, I don't know. It's so stupid though. So then rebalance after. Okay, so at this point we have our balanced heaps, right? And I guess in this case somehow I don't know if the max heap has more or the min heap has more, so let's actually print min heap and then let's print max heap. Let's print both. So the min heap is 3 and okay. So it's odd, right? Oh, because yeah, that's right. The max heap will always be bigger, right? Well, what if it's equal though? I guess if it's equal, they'd both have something. If it's odd, hold on. Actually, I'm confused now. Okay, we start with 1, right? 1 goes to this, then goes to the max heap or min heap. Min heap is too big, so we gotta move it to the max heap. So 1 is in the max heap. Then we have 3. 3 is in the max heap. We push it to min heap. So 3 is in the min heap and 1 is in the max heap. Oh, that's right. Oh, in a tie case, it will always just go to the max heap. Got it. So this, if at any point the min heap is larger than the max heap, then we'll push it to the max heap. So when in doubt, basically just put it to the max heap. But this if check, is it intuitive if the length is greater than? Is the approach like where you keep both a max and min heap so that we keep switching between min and max? At the end, we get our answer for each window. To maintain the window, we could take a deck. I don't think you use a deck for this problem. Apparently all you need for this, well, at least the solution I know how to do this, or I'm looking into, is maintaining 2 heaps and a dictionary. I don't think you have to do anything with a deck. Yeah, 32 days left, Moku, yeah. Or it might be 31, I'm not sure. Maybe it's 32, including today. All right. Okay, so if at any point the min, so we're always defaulting to the min heap, right? So in any case there's a tie, like in this case, right? We will always just switch it up. I haven't solved this problem before, just brainstorming. I mean, that's fair. I mean, This question is out of my league. That's all I can say. Definitely learning a lot though, I guess. Or I'm learning a new pattern I've never seen before. Hella cringe, but all good, I guess, that they asked this. I swear though, if they ask a question like this, I don't know. Part of me feels like they just want you to fail, but there's way easier questions than this one. It is what it is though. Yo, congrats, Hectic. Good stuff. Good stuff. Finally diamond now. And also, I don't think the deck works because, I don't know what you would do with the deck. I think the whole like point of this problem is like you're maintaining the sorted list basically at all times without having to like resort at every window. The naive solution is obviously not too bad, but the optimal solution is not as intuitive though. Okay, so let's continue. I think so far everything makes sense here.
Heap Q, heap pop onto the min heap, right? So we take the positive element, the smallest element from the min heap, pop it, and then add the negative because remember the max heap needs to use negative numbers. Okay, so at this point we basically have our first k elements. Now at this point we need to calculate the median. So what we're gonna do is we're gonna say if
We need to calculate the median. Okay, that makes sense because we basically do our first case, right? So let me just code that up ourselves. So if k modulo 2 is equal to 1, which means it's odd, and then else this is even. So in the case that it's odd, right, we can also maintain a result variable, and we can simply just res.append, I think. Like we said, for the way that we structured it, it's always just going to be the max heap of 0, right? And then if it's an else case, it's going to be a combination of the max heap plus the min heap, or max heap of 0 plus the min heap of 0 divided by 2. We're gonna have to probably put this in parentheses. Let's just make sure that he writes the same thing.
k is actually odd, then we need to basically take whatever's at the top of the max heap. And the reason that we allow the max heap to actually have one more element than the min heap is that in the case that k is odd, then we just need to take whatever's at the top of the max heap because that will be the median in our case. So in the case that k is odd, the item at the top of the max heap will actually be the median itself. If it's even, then we just need to take the top of the max heap, the top of the min heap, add them together, and then divide by 2. So we're gonna check if k is actually odd. Then all we need to do is say result.append. What we want to take the minus of whatever's at the top of the max heap. Again, remember the max heap is storing negative elements here, so we just
Fudge, it's negative. Oh my god. That's right. I gotta always remember that max heaps are storing negative values to maintain a max heap. There's no such thing as a max heap in Python. Right. So it's actually negative max heap, and this is also negative max heap. Correct.
we just need to flip the sign. And then we take whatever's at the top there, because that is the median in the case that we have an odd amount. Otherwise, if it's even, then we need to do some math here. So we're going to say res.append. What are we going to append? So we're going to say minus the max heap, so whatever's at the top of the max heap, plus whatever's at the top of the min heap. Oops, min heap of 0. And then we need to just divide this by 2, and that is our median. So pretty straightforward. That's how you calculate median mathematically. Okay, now we process the first k elements.
Okay, yes, I agree that so far that everything we've done so far is actually not too bad.
Calculated our first median. Now we need to basically do this for the rest of the medians. So we want to basically just move our sliding window up by 1 each time. Now this is where this problem gets tricky. I think there's two hard parts of this question. Understanding how to set up a heap in the beginning. This part is easier. And then now what's going to happen is we have to actually sort out how to add an element and remove an element and basically keep track of what to do with our heaps. So pay attention, this is the tricky part. I'll do my best to explain it. So we're going to say for I in range. Now we need to...
Okay. So you go... So now you go... For I in range of k. Is it k? I don't think it's k though. Shouldn't it be from k to the length of nums? Is it not?
basically calculate the rest of the elements. So starting at k up until the length of num, so the rest of the numbers.
Yeah.
we're going to say that the previous number, and this is going to refer to the number that we now need to remove. So for example, we have these three numbers. When we go to our next one, we now have taken this -3, added it to our window, but we also need to remove the 1 because
We need to remove the 1. But how do you know to remove the 1?
obviously slide it over by 1. So that previous number is always going to equal to nums of the current index minus k. So k
Oh, the previous number.
before is basically the one that we just added by moving the sliding window 1 forward. So now this number has been technically removed, but it's still in our heap, so we haven't popped it yet. So we need to basically add this to our heap dictionary to indicate that this number is in our heap, but we haven't
This is in our heap,
actually removed it yet. So we want to keep track of the count of how
but we haven't removed it yet. Alright, peace out, man.
many numbers we need to remove. So previous number will now have its count incremented by 1, which later on we will actually remove it from the heap, but not quite now. So now what we want to do is we actually need to determine what the balance of our heap will be now that we're removing an element and that we're adding an element. So remember that our max heap and min heap are considered balanced in two cases, right? The first case is that heaps have the same number of values. That's the first one. Or the max heap has at most one more value than the min heap, right? In the
Max heap has at most one more value than the min heap.
these two cases, our heaps are said to be balanced, right? Because this is the invariant
Correct.
we set for our heap that we want to maintain for this problem to work. So anytime we consider it to be balanced is if both of these things are true. So now what we need to do is determine what the balance is based on this previous number. So we're going to say that the balance is going to equal -1 if previous number is less than or equal to the median. Otherwise, it's 1. Now let's think about this statement. If the previous number is less than the median,
If the previous number is less than the median,
that means that when we're
if the previous number is less than the median, then if we removed from the left side, that means we removed from the left side, right? Which means that I wonder if we need to rebalance it by popping the min to the max, right? Because we need the right side to maybe rebalance with the left.
moving it from our window, this obviously the previous number is less than or equal to the median. This will come out of the max heap because the max heap
Correct.
stores everything to the left of the median, and obviously this number is either to the left or it is the median, which means that our min heap is actually going to be missing an element. So
Yes.
-1 represents the fact that the min heap is actually -1, so it needs an element to be
The min heap.
balanced. Otherwise, if this number is greater than the median, then that means that we're going to have to remove this number from the min heap, which means that our max heap is now going to have one more element.
Yes.
Or potentially two more elements than the max heap, right? Because remember, it can either be balanced if they're the same, or if there's one more. So potentially there is one more element that we need to take into account for the balance, right? Because this means that we have to remove from the min heap. So that is the current balance, and that is based on just the number that we need to remove from the left. Now, obviously, we just took a number, so now we need to account what's going to happen to the balance. So we're going to basically go through the two cases here. So if the nums of I, so the number that we just took is actually less than or equal to the median, that means that it's going to go into the max heap because it basically will store everything to the left of the median or equaling to the median. So if this is the case, then obviously we've now just added a new element to our min heap, so we can increment the balance. And balance really just represents kind of the state of the max heap, because that's really what we're interested in. So we're going to increment 1 to the balance because we've now added an element to our max heap. So in this case, we want to then push the element onto the max heap. So we're going to push minus nums of I. Okay, so that is the case when the number gets added to the max heap. Obviously, the flip side is if we're adding it to the min heap. So in this case, the min heap will get an extra value. So now the balance needs to get decremented by 1. Because now the min heap is getting an element, which throws off potentially the balance of our max heap. So now max heap is potentially has one less element, and we need to take that into account. So that's why we decrement the balance here by -1. And then we also need to put that element onto the max heap, so the min heap, and we're going to do that now. So we add, so we're going to add the number to the heap here. Okay. Now what we need to do is take into account what is happening with our heap, right? Because our heap may not actually be balanced. So we're going to say if the balance is actually less than 0, what does this mean? If the balance is less than 0, this means that the max heap doesn't have enough elements, right? So we actually need to get rid of an element from the min heap and put it onto the max heap, because potentially we got rid of an element from the max heap, and now the min heap has more elements. So we want to make sure that we actually have our balance back. So what we're going to do is we're basically going to say heap q dot heap push. So we're going to push onto the max heap an element from the min heap, basically restore the balance. So minus heap q dot heap pop of whatever is at the min heap. Okay. So that is the case when the balance is less than 0. So this is the case where the max heap needs elements. Otherwise, sorry, not else. It should be else if the balance is actually greater than 0. Then that means that the max heap has too many elements. So in this case, we actually need to get rid of an element from the max heap and put it onto the min heap to balance things out. So we're going to say heap q dot heap push. So we're gonna push onto the min heap whatever's at the top of the max heap, basically rebalance the elements. So we're gonna say heap q dot heap pop max heap. And be careful here with the minuses, because in this case we need to minus an element from the min heap to basically put it onto the max heap, and then here for putting something onto the min heap we need to flip it from negative to positive because we're taking it from the max heap. So be very careful here because it's really easy to screw up these minus signs, and you need to be careful when working with a max heap and an min heap in Python. So and then there is actually no else case, because if the balance equals 0, then that means that our heap invariant is satisfied, so we don't need to do anything because the heaps are balanced based on the rules that we set, which remember are that they either have the same amount of elements or that the max heap is allowed to have at most one more element. So in that case, everything's fine. We actually don't need to do anything there. Now what we want to do is we actually need to clean up our max heap from any elements that potentially we need to remove, right? Because we're storing in heap dict elements that we need to remove. So now is the time to do this. So while the max heap still has elements in it, and heap dict so minus max heap of 0. So basically, while the heap dict has a count greater than 0 for that element that's at the top of the max heap, we need to remove it. Because at this point, if it's in the heap dict, we only put the previous number. So these are all numbers that have already left the heap. So we just need to get rid of them, right? So we need to decrement the count of that key in our dictionary. So we do we need to decrement the key of whatever's at the top of the max heap, and then we're just going to pop from the top of the max heap to get rid of it. So heap q dot heap pop from the max heap. So that will clean up the max heap. Now what we need to do is also clean up the min heap, and the logic is exactly the same, but we'll just do it from the min heap. So while min heap and heap dict of min heap 0 is actually greater than 0, so while we still need to remove things that are still in the heap, and it's at the top of the heap. Now, you may be wondering why we're only doing this for heap 0, because essentially we want to remove it when it gets to the top of the heap, because that means that we can get rid of it in constant time. If you pop from the top of the heap, this for heap, also clean up the min heap and the logic and heap dict.
Oh, this part is so confusing. Is the second half not finished? Optimal. It's the best known method. What the fudge? It tracks how heap sizes should shift after removing prev num and adding a new number. The balance is greater than 0. Min heap has more. Rebalance to max heap. Balance is less than 0. Max heap has more. Rebalance to min heap. The heap dict is a default dict. This is optimal.
Of min heap 0 is actually greater than 0, so while we still need to remove things that are still in the heap, and it's at the top of the heap. Now, you may be wondering why we're only doing this for heap 0, because essentially we want to remove it when it gets to the top of the heap, because that means that we can get rid of it in constant time. If you pop from the top of the heap, you don't have to then rebalance the heap, and this is the most efficient way to do it, because if you think about it, when we calculate the median, which you'll see in a second, we're only ever using the top of the heap and basically the top of the heap for both of the heaps here. So we don't actually care about what other elements are in there. We're only ever working with the tops of the heap. So we don't care about the order of the other ones. We just care that the top of the heap is what we need it to be. So that's why that we want to take care that when something that should be removed from the heap actually makes it to the top of the heap, we actually get rid of it, because as you see, the way that we calculate the median is only based on the top of the heap, or basically the top of both heaps. So the order of the other elements doesn't actually matter. Okay. That little ramble aside, let's now do the same thing. So we need to decrement the count of whatever's at the top of the min heap by 1, and then we need to pop from the min heap. So heap q heap pop from the min heap. Okay. Now what we need to do is simply just append the result for this case. So as you can see, we still haven't calculated the median. Now we've taken care of basically balancing the heaps, making sure that we removed an element correctly based on how the previous element was removed, and then we also added our new element, so we took that into account. Now the last thing we need to do is actually just calculate the median. So what we can do is just copy and paste this code here for calculating the median, and paste that there, fix the indenting, and then this will basically calculate the median. Again, if it's an odd, okay, then we just need the top of the max heap, otherwise we do the mathematical calculation, and we just append that to the result. And that's it. So once this for loop ends and we're my indentation, all we need to do is simply just return our res, and we are done. Now, tricky part, did I make a mistake coding this up? I would say yes, but let's see. Now from
this second part is confusing, I think. This balance part.
-1, so has 1 forward. So now this number has been technically removed, but it's
Yes, prev num, we aim to remove it.
still in our heaps because we haven't popped it.
Yes, it's still in the heap. Well, I don't know about heaps, but it's in one of the heaps.
Yet, so we need to basically add this to our heap dictionary to indicate that this number is in our heap, but we haven't actually removed it yet.
So we say heap dict plus equals 1 to say that it's in the dictionary.
So we want to keep track of the count of how.
I guess to keep track, right?
how many numbers you know, we need to remove. So previous number will now have its count incremented by 1.
How can it be ever greater than 1?
Which later on we will actually remove it from the heap, but not quite now. So, oops, now what we want to do is we actually need to determine what the
What's up, Kyle?
balance of our heap will be now that we're removing an element and that we're adding an element. So remember that our max heap and min heap are considered balance in 2 cases, right? The first case is that heaps have the same number of values. So that's the first one. Or
the max heap has one more than the min heap.
the max heap has at most, fuck, I can't type, at most one more value than the min heap, right? In these 2 cases, our heaps are said to be balanced, right? Because this is the invariant we set for our heap that we want to maintain for this problem to work. So anytime we consider it to be balanced is if both of these things are true. So now what we need to do is determine what the balance is based on this previous number. So we're going to say that the balance is going to equal -1 if previous number is less than or equal to the median. Otherwise, it's 1. Now let's
Balance is -1 if previous number is less than or equal to median, else 1.
Let's think about this statement. If the previous number is less than the median, that means that when we're removing it from our window, this obviously the previous number, if it's less than or equal to the median, this will come out of the max heap.
Correct. It comes out of the
Because
max heap.
Max heap stores everything to the left of the median, and obviously this number is either to the left or it is the median.
Oh, because if it was 0, I guess it just has to be -1. I don't know, bro.
Which means that our min heap is actually going to be missing an element. So -1 represents the fact that the min heap is actually -1. So it needs an element to be balanced. Otherwise, if this number is greater than the median, then that means that we're going to have to remove this number from the min
I'm gonna have to
heap, which means
yes.
that our max heap is now going to have one more element.
Which means the max heap is gonna have one more, which is also imbalanced. Right? Well, it could be. I don't know. I guess if it was actually even. I don't know actually.
Element, or potentially 2 more elements than the max heap, right? Because remember, it can either be balanced if they're the same, or if there's one more. So potentially there is one more element that we need to take into account for the balance, right? Because this means that we have to remove from the min heap. So that is the current balance. And that is based on just the number that we need to remove from the left. Now, obviously, we just took a number. So now we need to account what's going to happen to the balance. So
We just took a number and account for the yes.
So we're going to basically go through the 2 cases here. So if the nums of I, so the number that we just took is
The number that we just took.
actually less than or equal to the median, that means that it's going to go into the max heap because it basically will store everything to the left of the median or equaling to the median. So if this is the case, then obviously we've now just added a new element to our,
Max heap.
min heap. So
Wait, what?
we can increment the balance and
What?
median or equaling to go into the max heap because it
Yes.
equals to the median. That means that it's going to go into the max heap
Correct.
because it basically will store everything to the left of the median or equaling to the median. So if this is the case, then obviously we've now just added a new element to our min heap.
I think he misspoke. I think he meant to say max heap.
So we can increment the balance, and balance
So the balance of -1 represents the min heap? Is that what that means? Oh, I guess that makes sense. because we start at -1. If we took out something from the max heap, but we also add something to the max heap, then it balances back to 0, right? I think that's the reasoning, the reason why it works. Because what ends up happening is that if we do add to the max heap or min heap again, if we took out from the max heap but add to the min heap, then we're actually unbalanced. So then the balance would be like -2 or something like that.
Balance really just represents.
Dude, my head hurts. Not from studying, but like, my head hurts. Let me just do a gaming break. I need to pass time. My head is like, I can't study right now. My head is in pain.
Match found.
It's okay, it's not that bad. Could be worse. I'm sure it'll go away in a bit. Hopefully.
Get zapped.
Is it bad? I've experienced worse. It's tolerable. Not dying. Could be worse. Could be worse. Could be worse. I mean, hopefully it's over in like the next 20 minutes. I hope it's like a relapse phase. Can I get a water? I really need to have some vitamin D on hand, I feel like. Let me just buy some vitamin D, actually, on Amazon. So, like, I have vitamin D. One-time purchase. What's up, Jabis? Thank you for the...
W Legu.
Thank you for the prime.
Don't worry, everyone. I won't
Appreciate
tell them what
you.
scares you. Promise.
Oh. Check out one item. Pay method. Deliver. Fastest by Thursday. Should be fine. Alright, place order.
I'm out of here.
Okay. I was sitting, it's not bad. But my head's hurting right now, so. Taking a break.
Enemy spotted A, right where I thought. Enemy spotted A.
Spike planted. Yoru's down.
Enemy spotted A.
Last player standing.
Oh, he knew. And our Clove TP'd. GG. Yo, are you stupid, Clove? Whatever. I don't care. I think I bottled it? What does that even mean? What is
Listen for
I've
the
never
wind.
heard that
It will
before.
tell you where their jet is.
Is that a good thing or a bad thing? Bottled it? Is that a good or a bad thing? God.
Gotta go.
Oh, you think you failed? It's okay.
Enemy spotted A.
Kill. Go, go, go.
Found one. Sleep.
You're stuck in there.
Enemy spotted A. Stay down.
Wait.
One
is it a
enemy
fake?
remaining.
Spike planted.
It was fake.
Enemy spotted A.
Who's next?
Not a I'm out of
Bro,
here.
you can't ult while you're still visible. Hello?
My Lola was right. Weeds are difficult to kill.
Just sat there thinking for half of it. Oh no. That's not good.
I'm out of here.
Understood everything my tutor said, just couldn't respond. There is that, I don't know if it's like a phenomenon or something, but yeah, there's a thing where like, you know, when you learn something, everything makes sense, but like
Rather win.
the true learning happens when like you're
Go, go,
able to
go.
recite it yourself, so maybe the concepts didn't solidify in your brain.
Enemy spotted B.
Gotta go.
Yo, go A.
Got one. Coming through. Gotta go.
Oh, Leetcode. Wait.
Last player standing. I'm out of here. Here we go. Running low. Go, go, go. One enemy remaining. I'm out of here.
Oh no! Watching the master at work. What's up, Betsy? Oh.
Last round in the half.
Oh, my head.
Let's go.
I'm in pain, bro. Pain, bro.
Ah, break's over.
I need to rest. I
Gotta
mean,
go.
I guess I could just suffer more comfortably.
Enemy A.
Prepare for hellfire!
Go, go, go.
One dead.
Reloading.
Spike down A.
No, I thought I killed her. Oh, I'm so bad.
Last player standing.
Oh my god, our teammates are so bad too, though.
Switching sides. I'm out of here.
One dream ends, another
Dream.
begins.
Oh.
Gotta go. I'm out of here. Go, go, go.
Oh god, I really hope this is like the last one.
Gotta go.
I'm out of there.
Hi, bye. Healing.
They're dead.
Spike down A. One enemy
Smart
remaining.
move. Go, go, go.
Our teammates are
Almost
so
out.
ass, bro.
I'm out of here. Gotta go.
They went back. So obvious he went back. I don't think he actually
30
planted.
seconds left. Spike planted.
Go, go, go.
So obvious, bro. So obvious. Do you even know who you're playing against? Come on, man.
I've tried to. I'm out of here.
Yo, what's up, Jake? I'm playing Swift Play though. It's Swift Play.
Ugh, I'm
Why are
over
they
them.
giving him 1v1s? Yeah, that's because they're bad.
Go, go, go.
You guys playing Minecraft? Maybe I'll have a new thing to play with for breaks.
Can't hide from me.
Perhaps soon.
Need a drop.
Marked one.
Oh my god, wait. Timing? Like, what is he doing? And why does he have... Oh my god, and he left.
Enemy spotted A.
How does the leaning thing work? Wait, what's the leaning thing?
Last player standing.
What's the leaning thing? Oh, yeah, yeah. It's just the gun. Ew, ew. Yeah,
Match
it's the way the
Perhaps I will
yeah,
not
this
have
this
my
person
back.
needs
Very little time
needs
to
some aim
react
labs.
once you
I'm
start
outta
the
here.
fight.
But yeah, it's just the way the gun skin is. It leans on the ADS. It's kind of cool. Apparently, some guns are actually like this in real life.
They are mine.
Apparently, Soba needs coaching.
Prepared for hellfire.
Marked one.
True. GG, bro. GG, bro.
Enemy spotted A.
Please get one Sage. GG, bro. They know.
Spike planted. Last player standing.
Oh my god, my teammates are so
Attackers win.
ass. It's okay if you win, then you win, but if you lose, it means you'll get tilted and do Leetcode. What is better though? What is better though? Okay, I think my headache is dying down. I think one more. I can come back to studying. Yo, Betsy, what do you think about this problem? Yo, don't you? I mean, okay, I will say, like, if you know the question or know the solution, like I think it's fair, but like I still feel like someone asking a question like this is
Match
crazy.
found.
Like this is crazy. Like you're I feel like you don't want to pass the candidate if you ask this question. It's like there's so many easier questions to ask. I feel like it's cruel. The world is cruel.
I've got all the time in the world.
But where's the fun in that? True. Just gotta be the best, I guess. Just be the best in the lobby. Just gotta try hard everything.
That's my double, yeah? I got her.
My head, bro. My head. Just makes me want to like rip my left eye out. I actually wonder if there's people that have done that and it still doesn't go away.
Reloading.
I'm playing, but I'm playing casual. As I always do.
Gotta go.
We choose to delete code and systems.
Enemy B. Reloading.
Adios.
For you.
Dropping smokes.
I got
Spike
spike.
carriers down.
Spike
Reloading.
down B.
Reloading.
Reloading. Right. Our spike carriers down. Refreshing.
Spike down B. One enemy remaining.
He's
Right
here.
here.
Wait, we didn't play it yet.
Not
Oh,
ready
he's
yet.
gonna
I
do
got
some
the
crazy
spike.
stuff. I know it. I just know he's gonna do some crazy stuff. I'm already,
Click on him.
I already know what he's gonna do. He definitely like went flank or something.
Spike planted.
Last player standing.
He's ready for that. So
Not gonna
cringe.
Shock dart.
Get me out. I didn't know JFK. I didn't know Leetcode was invented when JFK was president. Yo. Oh my. Whoa, is that timing?
Nice job.
We're calming in Swifts.
Right then. Some more of that. Near in the shite.
Nice. No, one smoke. Just need one smoke. Got the cracked Leetcoders. I know. The Leetcode game has been out for too many years. These people are actually low key. I don't know. Do you feel like the bar got higher? Like the fact is, like, I feel like the bar has always stayed the same. Low key.
Go, go, go.
No
spike.
charges.
Reloading.
I'm out of here.
Oh, GG.
Dropping a smoke. You fought well. Spike
Oh yeah. Okay.
Spike down B.
That makes makes sense.
I have the spike.
That makes sense, by the way. Yo, hello. Are you gonna? No. Help your goddamn teammate.
One enemy remaining.
This guy this
Last
person
player
choose.
standing.
Oh my god, get me. No, this crosshair placement is so bad. Ew. Back in the day, you passed knowing twosome. Is that true though?
Clutch.
Oh, I don't know. I actually wonder if it's also RNG. I wonder if some candidates have it easy, you know? They just get the luck of the draw and they don't get like that many hard questions. Like medium to easies versus like mediums to hards.
I'm out of here.
Yeah, it's RNG, which I mean, it's like Valorant. You could do your best and still lose. Which is annoying, but it is what it is. It's just a numbers game.
I would settle for a draw.
It's all about the percentages. As long as you can just maximize that percentage.
Revealing area.
No peeking.
Shot down. Reloading. Shot down. Neutralized.
Healing you.
My ult is ready.
Wait.
Here, your duty
Is not over. That sucked.
Do we know all three?
here.
No peeking.
There's two.
Spike planted.
Last player standing.
Jed, are you gonna do something? Like, how long are you gonna take?
One enemy
Wait,
remaining.
wait. Where's smoke? There's smoke behind to make him think something. Make him. But wait a minute.
This is what I
Redeemed
trained for.
himself. Can control how many chip on the
Last
shoulder
round before
people
the
you get
switch.
in their
You cannot
interview.
keep our
Can
good
control how many patterns you.
Need a drop.
Oh, can control. Yes, I agree.
But I'm
I
at
agree. 100%. 100%.
Here.
I don't get it. Why are there people that just end up being interviewers and being dicks about it? I don't understand what kind of human being you have to be somebody like that. Like why you glazing your why you like D1 glazing your own company? Like that company don't care about you. Well, why are you being cringe and gatekeeping? That's just weird.
Go, go, go.
What is this?
Gonna smoke.
Nice, bro.
Spike planted. My ult is ready.
One enemy remaining. Team A.
Nice team.
Were they born yesterday or something?
Switching sides.
Nice team. I've seen some terrible people who got. Yeah, it's like the same thing as Valorant. Like, there's people that are in their rank that don't deserve it. I don't know. I've heard some stories about like, I don't know. It's like nepotism or like, you know, like people that like aren't actually. Oh, I don't know. I've also heard of plenty. Like a lot of people cheat nowadays too. And that's the thing. So it's just I don't know, dude. It is what it is, I guess. Just. After this, I definitely gotta just interview more, that's for sure. But I feel like I need the referrals though. I feel like that's the hardest part. Getting the interviews.
Gotta go.
I'm just baiting the hell out of this. Okay, this neon is just doing nothing. Nice.
Gotta go.
Get lost.
peeking.
Neon is so brain dead, bro.
Spike planted.
Oh, we're bringing it back on site. Oh god, it's too expensive, no? I guess for a company like you probably don't matter. Like, it doesn't
One
matter.
enemy remaining. Last player standing.
There they are.
Ooh. Ew. Yo, you had wall hacks and you still can't kill the guy?
The enemy only looks
Oh my
composed.
god.
Their hearts do
Disgusting. Disgusting.
Need a drop.
I remember my Google friend would be like in high school and like he would just travel to like Cali and he gets his expenses paid for. I feel like it's so expensive for the company to do on-sites now. Maybe it's cheaper.
Drop in a smoke.
Spike planted.
Have a kit. Refreshing.
Last player standing.
Ew.
I'm out of here.
We're doing on-site? Oh man. I don't know. We also don't really care about money.
Oh, this reminds me of this
I
one
guess if you're
time
that,
where
if you guys are making that much money, yeah, I guess it doesn't really matter.
Never mind.
Took a bunch of final rounders to a Knicks game. What the hell? Why do you guys owe anything to final rounders? They didn't even make it. That's crazy. It's kind of you guys though.
Fire in the hole!
Opponent killed. Here. Eliminate. My ultimate is ready.
Spike
Actually,
planted.
easy.
No peeking.
Wow, he hits me.
Last player standing.
Neon, do something.
One enemy
Yoru's
remaining.
down.
All right, if you win the round,
Go,
I
go, go.
won't be mad.
Are
Wait.
you kidding me right
Oh my
now?
God, he's so bad. He's so bad, bro. One of them passed.
My
Match
ult is
point.
ready.
That's crazy.
They demand a fight. Who are we to disobey?
Does your company only ask hard questions? Do you guys only
I get that?
get the cream of the crop? Is that how it works? That's crazy. Jesus. That's like, that is sweaty. That is sweaty as frick. Do you think it's also like you probably won't pass unless you've seen it
Go, go,
before?
go.
Or maybe you've just solved so many questions at that point, like you've just seen all the patterns.
I'm out of here.
Enemy spotted.
No peeking.
I'm bad.
Spike down A.
This neon is... Wait, back.
Like I never left.
One enemy remaining.
No. No. It's another effort. Yes, get his
No one
ass.
escapes my sight.
Get his ass. I've done like 3 to 5 on-sites per
Sudden
week for
death.
the last 4 weeks and no one passed.
I'm out of here.
That's just crazy. All that work and no one passes? That's so sad. But I feel like coding interviews don't care about like who's the best candidate, right? It's just whether you pass the bar or not. That makes sense. That makes sense.
Alright, muckers.
That
Off we
makes
go.
sense. That makes sense. GG. Oh my god, I get jump scared. Alright, this guy's cringe as hell.
No more.
Neon, are you gonna have your gun out?
Last player standing.
Oh, GG.
Spike planted.
Sleep, brother.
Wait a minute.
was
Can we
wonderful.
win?
My
Wait.
ult is ready.
You're throwing? You just updrafted. Wait,
Revealing
I
area.
just Reina blinded in the open like that.
One enemy remaining.
Wait a minute. Can I smoke him?
Drop in a smoke.
Concentrate,
Oh!
Nice job.
Dude, you're cracked.
Wow, they're so bad.
A.
I
Defenders
am the
win.
hunter. I'm not
Am I
tired.
feeling better?
You?
I think the fact that I haven't had to think about my headaches means that I'm probably better. I still feel it though. Maybe I give it one more game. One more game. Chad. Do you guys also time it based on like 20 minutes per question? Is that like a standard?
Match found.
No? Oh. Oh, you guys don't have Leetcode? That's fair. I heard Google's less like that too. Or like less Leetcode-y. It's interesting how Meta just doesn't care. I think they just want people that know how to like memorize stuff, I guess. Which is why I feel like my chances should be decently high.
Move or get zapped.
In theory. Oh, the data structure you need for it on the job. Damn. That could be like luck too. Because like if you end up using that data structure for your actual work and then you get that question, those people would definitely have an advantage. But I guess you just have to know all of them. Just be a good all-arounder. Oh. 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 Oh.
Neon,
Oh.
just saying. Wind, lightning, we could make a storm. Sounds reckless. Sure, why not?
I write my problems. You write your own problems? That's crazy. Do you ask DP or no? What's your thoughts on DP? No DP? I think DP's cringe. I think we should ban DP.
Gotta go. I'm out of here.
It's always A, bro.
Oh my god, I got one!
Spike down A.
You're a DP fan? What do you like? Do you like top down or bottom up? Oh, there's one
Spike
belt.
planted.
Enemy spotted A.
Last player
No,
standing.
this wall is trash. Why are you walling up for? You stupid Viper. You're helping them. Oh my god, they're already inside, bro. Bottom up almost always. I forget which one was the like more unintuitive. Is it bottom up that's the more unintuitive? That was one that I felt like
Go, go, go.
was always the not very intuitive approach. Like somehow you just had to know how to do one or the other. I forget which one. I think it was bottom up. Oh yeah, okay, that makes sense.
Spike down B.
Bottom up is without recursion. Is it actually? I don't know. Like, so if you had the option to do,
bitch.
if you had the option to do DFS
sorry, that
or
was me.
BFS,
It's okay. I deserve
and they're the
You
same
sound like a friendly
time
fellow.
complexity,
Spike planted.
is it just better? Is it objectively
Yeah,
better
that's-
to just use BFS because you don't use the recursion stack? This guy's try hard. What the hell was that flick?
Last player standing.
This guy's trying to hit a click. You got it right. The recursion stack is wasteful.
Gotta go.
Suppose so. I suppose so.
I'm out of here.
I just buy a Marshall. I feel like Marshall incentivizes me to like actually shoot the head more.
I'm out of here.
Watch this, chat. Get the hell out of here, Jed. This is my space. Oh my god, I messed up.
Shit, I
bro.
couldn't break line up. I'm so sorry.
Go, go, go. Work good.
Still got mine, so I'm chilling. What am I doing, bro? What am I doing? How is everyone dead? Whatever.
Spike planted. Last player standing.
Nice. Damn. Is this ranked? There's one tap in heads like that? I missed my freaking jump though.
Last round
Frickin-
in the half.
I blame the freaking jet.
Everything you have.
We lose it anyway.
Gotta go.
I don't know why that guy's in my freaking way. I'm gonna try it again.
Let's take at least one down with us.
I'll get it this time.
Duck, my
Gotta go.
they will cover. Enemy spotted B.
They know.
Welcome to my world.
Spike planted.
Rest. My ultimate is ready.
One enemy remaining.
He's freaking. How am I dead?
Your duty is not over.
Oh, please win this. Why is nobody peeking?
I got a kill. Let's go.
We cannot let them unweave our world. Can't use this yet.
Switching sides.
They stumble.
I'm out of
Now
here.
is our chance.
I also like BFS better than DFS too. I don't know. I feel like. Yeah, I still feel like I'm not that great at recursion. Like, some parts of me still feel like it just. don't make sense. I think it's hard to figure out like what I need to send up back to the parents sometimes.
Gotta go.
I think traversing is usually not too bad, but it's like usually like
I'm out of here.
the bulk of the logic in between. I feel like that's like the hard part. I'm gonna let him go.
Killed. Nice try. Coming through.
Spike down B. One enemy remaining.
Oh, I almost styled on his ass.
Spike.
Oh my god, I almost styled on him so hard.
You were
Oh my god. That was almost crazy.
I'm the last thing they'll see before they die.
Gotta go. I'm out of here. I'm out of here. Go, go, go. Go, go, go. Keep up. Gotta go. Gotta go.
How hard are my teammates gonna
Last
bait
player
me,
standing.
bro?
Spike down A.
Oh my god. Jet is trash.
Match point.
I'm out of here.
I hate this game.
Go, go, go. Gotta go. Go, go, go.
Hit this guy for 97. This guy just one taps me. Come on.
I'm out of here.
That makes sense.
Gotta go.
I'm lurking. I don't care. Neon's out. Whatever. I'm done.
Spike's down. Blocking sight.
Spike down B.
Damn.
Last player
Oh, he almost
standing.
had
My
that.
ult ready.
Hello, Reina. Are
Defenders
you gonna do
win.
something?
Fight! I'm pissed.
Am I done? I feel like I still can't focus. Oh, wait, are they playing? I'll give it 5 seconds. 5, 4, 3, 2, 1. Boom. All right. While we wait, let's go back to this question. Do you want a framework for the problem that you're doing?
Match found.
This one right now? Okay, what? Hold on. I feel like, okay. I get the first part. So like, I get that the first part is basically you're maintaining a max heap on the left, min heap on the right. And depending on, you know, whether it's even or odd, you maintain, you know, the first case. Second part, I know it's just about the balance and like setting it to -1 if it's like if you're taking out of the max heap, and it's a 1 if you're taking out of the min heap. and then you like you tilt the balance based on what you add, I guess. Is that right? It's very high level, yeah. So what do you mean by framework? You mean like lower level?
Move or get zapped.
Doing this in Python is harder than other. Really? Really? Is that so? Let me see. Let me see what it looks like. Oh, this is whatever.
Clove, you were up at 3 a.m. watching cooking videos. How are you awake right now?
Wait,
I'll sleep when I'm
priority
dead.
queue is a.
Which I guess is
Oh.
never.
Wait, is a priority queue a built-in data structure in C++? Wait a minute.
Reloading.
Doesn't Python also have a priority queue? I'm not sure. I don't remember. They also do need to do a lazy pop. What is lazy pop? Is the lazy pop like the balance part?
Gotta go. I'm out of here. I'm out of here. Gotta go. Next.
Oh
There.
yeah.
Go, go, go. Shortcut.
I was stunned. Oh, GG.
For you.
Oh
One
god,
enemy
ew.
remaining. Last player standing.
Oh, I suck. It's the part where the window moves and you need to remove an element from your heap. But you can't remove an arbitrary element from the heap.
Just gotta
or the
play around the
yes,
field, and we're
yes.
fine.
Which is, I think, the difficult part of that problem. So you're telling me in a different language there's something, some data structure that's built in that makes that part easy? Like C++? Use a binary search tree.
Come on in.
I'm ass, bro. I'm ass cheeks.
Go, go, go.
Booty cheeks.
Someone's in defender spawn.
One enemy remaining.
Reloading. I'm out of here.
Still on A, boys. Oh, I'm so ass.
Last enemy taken out.
You can still do it in Python though with lazy deletion. Why is it called
I
lazy?
belong here. We all belong
Oh,
here.
who named it lazy? Why the heck is it lazy? Yeah, if you do it through the heap, I
Shoot
guess
them.
it's still log
Always
n.
works.
So they're both, I guess, just as efficient, but I guess the other language have it more built in. Oh, wow. Res me, please. Oh, this person's not gonna res. Like, is that just not the most free, obvious res to do? I don't know. That's just me. That's just me though.
Spike down A.
Dang it.
Your duty is not over.
Yo, Sage.
One enemy
Oh
remaining.
my. Got some shooters.
Spike planted. Drop in a smoke.
Wait, but in C++ you still do this balance part. It's not the same?
Last round before the switch.
Last call for all the things we need to kill him
Then
with.
what the hell is a
Buy up.
multi-set? What the hell is a multi-set?
Need a drop.
Oh, multi-set is BST? Yo, hold on. There was this solution that GPT generated. I was wondering if you thought Meta would accept it or not. Hold on, let me find it after this.
I'm out of
Let
here.
me find it after this. Let me kill this dumb sage. Oh, you're lucky. You're lucky.
You will not
You're lucky
kill
I'm bad
my
at the game.
allies. Wall raised.
Oh wait, yo, Sage is in a good spot right now. Oh wait, no, somebody's gotta break the drone. Oh my god, it broke. Oh my god, Sage is in prime position. Beautiful. Main. All three.
No
my God.
peeking.
Last player
Yo,
standing. One enemy remaining.
yo. Oh my god,
Like
he's
I
back.
never left.
Play time. He's got a stick. Ooh. Wait, hold
Switching
on.
sides. That shit's
Was it
humble,
multi-set? Let me find it. Dude, my head still hurts, bro. How long is this gonna last? Really, it doesn't last more than an hour. Do God's work right now. Oh my god, these guys are so crazy. No. No. Of course they always clear it. It's too obvious.
Spike planted. Last player standing.
Reyna, the offer stands. Take whatever life you need from me.
Go, go, go.
Deserves it.
Gotta go.
Alright. Let me try to find it. I don't remember how far I have to scroll up. Oh, wait, was it this one? Using sorted containers. I don't know if that's the same thing though.
Go, go, go. Running low.
That's what you mentioned before?
Bad move. Gotta go.
I feel like they're going B.
One enemy
They
remaining.
actually go A.
Spike down A.
Guys are so try hard. He's gonna flash.
30 seconds left.
Gotta go.
But still, they probably would
Match
would
point.
Wind. So
Reply would act it works, but still ask you to do 2 heaps. Yeah, that's what I'm saying. Well, I don't know. Would they ask you to do if you did the 2 heaps method? Would they ask you to do this one too? I don't know if I could learn both. I don't know what the hell a sorted container is. It's a good dimension. What the hell is a sorted container?
Gotta go.
Oh. So what is this? It's basically a BST. So you're wait. So is what I'm writing basically a BST, but it's like a manual BST,
Spike planted.
or is there a way to? Oh, okay.
You will not kill my allies.
Last player standing.
Wait, so
I know what must be done.
I'm out of here. Go, go, go. Go, go, go.
that lets you query the value at some index. Interesting.
Almost out. Get out of my way. I'm out of here.
Of course, he's walked in. It's a lurking mother.
One enemy remaining. Last player standing.
He's wide, surely wide. He wasn't ready for it. Wasn't ready for it.
Sudden death.
Okay, we know the drill.
Stick to your roles and we'll crush it.
Damn, I gotta. Dude, there's so many data structures, man. How many data structures are there?
I'm out of here. Go, go, go. Go, go, go. Gotta go. I'm out of here. I'm out of here. Quick feet, quick trigger.
Oh, I don't care. I don't care. Give me out.
That's a kill.
I don't care. Alright. Multi-set and 2-pointer. Self-balancing binary search trees have some very interesting properties. They maintain the tree's height. The median always winds up at the root of the tree. What? Wait, so the root of the tree is always just a median?
Attackers win.
Why not? Let me research what this is. Actually, that's ChatGPT. What is this? Explain. This is overkill. Oh, don't. So I don't need to learn that. You're saying I don't need to go that far. Yeah, I don't want to learn it if I don't have to. That's so interesting. Okay. So they want you to mention it, but they don't actually want you to code it. Okay. That's so interesting. All right. I gotta understand how people like actually want to like what the meta is. How am I supposed to know like this is the approach that you're supposed to do? You know? Oh, like how are you supposed to know that? Because in my head, I'm just like, couldn't the interviewer theoretically ask for whatever? Because it's a meta? I guess so. I'm not out of the loop, I guess. Just not in the meta. It's not the way you're supposed to do it. Okay, fair enough. Would you penalize a candidate, though, for doing it this way? And they were able to explain it well? True. I'm almost done with my dailies. Alright, I need 3 rounds. I need 3 rounds out of me. And I can end my dailies. Guess we're just going B. If they do the sorted list way but can't write the 2 heaps, it wouldn't be a pass. Interesting. But if they do the sorted heaps... Oh, what if they did the sorted heaps but they didn't list any of the other possible solutions? Is that a fail? As well? Oh my god. A madman.
No peeking.
Surely flank, right?
Spike planted.
Oh.
One enemy remaining.
Refreshing.
Last player standing.
That's a pass? Oh, interesting. That is so interesting. That's okay. So I just gotta solve it the meta way. I just gotta solve it the meta way. But I guess it's extra credit. So like, do you guys also? Yo, it's kind of, I don't know. Like, I usually don't get feedback on my coding rounds. I actually got feedback from the recruiter, and apparently that's like usually not allowed.
Show me a target.
And I was asking him like, because okay.
Spike down A. Last player standing.
I'm interviewing with Meta, yeah. Oh! So like, apparently I scored like 2s and 3s. And then 3s like, I guess meets expectations. And apparently it's like rare for a candidate to get like a 4 or 5. I think it's like almost impossible for a candidate to get a 5. Is that normal? Is that like similar to how you guys grade candidates too? I mean, he did say also like if I didn't, if I did that on the onsite, I wouldn't have passed. And I was like, I bet. No, I didn't pass all the rounds. I mean, I passed the phone screen, but I still have to do the onsite.
I got the spike. Sorted.
Oh.
Fake teleport.
Last player
Yo,
standing.
hello. Sage got 3.
Last
My ult
round
is
in
ready.
the half.
You lose everything after this.
I don't care. I'm just gonna keep baiting my team.
player standing.
You will not kill my ally.
What the hell was that? Why was I missing bullets?
Switching sides.
Oh my god, get me out, bro.
Every fight
I
is
just
a
need
lesson.
2 rounds. Do you guys think 1 month is enough to practice or prep for an interview? I mean, I have been prepping for over a month, I guess, technically. Also, Betsy, I don't think I can do every single meta question. I think I might low-key just like speed run top like 75 or top 100 once I'm done with them and just redo them over and over again. I'm not sure. Genuinely unsure.
Enemy spotted
Spike down A. Last
He's
player
actually... Oh my god, he's actually doing nothing. I just can't. I just can't with these people. And they won the round for it. Oh my god, they're so just... Like, it's so dumb.
Match point.
So dumb. Getting Fang interview in this market means you're pretty smart. I don't know. I don't know, dude. I just feel like I don't know. All I can say right now is I don't think I'd be able to get it if I was in my current state. That's it. And also the bar is lower for this phone screen, so it's like I don't really know if it's
Cutting through.
Spike down A.
You will not kill my allies.
Cutting their vision.
they left. You guys are so try hard, man. You're so try hard, bro.
Spike planted. Last player
I
standing.
try my best. My team is ass. But yeah, apparently, like, meta, if you pass the phone screen, I think somebody said, well, this guy on YouTube says, like, if they think you have even like a 25% chance of making it,
Attackers win.
they will pass you, which is like a pretty low bar, I feel. So I guess like 1 out of every 4 candidates. I don't even know. I feel like the percentage might be even lower. Not sure. I mean, to be fair, I did get those scores without even like studying the meta tag list. So I guess like that is a W though. Oh my god, get me out of these disgusting Swift plays. They're disgusting. They're disgusting, man.
Match found.
Just ego peek them. Yeah, gotta be confident, that's for sure. I still gotta, I don't know, I still feel like there's still so much to learn. You know, it's like Valorant is like, I don't know. You know, to be fair, I haven't Leetcoded for like 3 years straight. If I Leetcoded for like 3 years straight, or like on and off, like a good amount, I feel like I definitely would feel the same way I do with Valorant, but I always do it in like bursts, which is bad, I feel like. But every time I do it, I do feel like I get better. Like this is the highest peak I feel like I'm at. terms of if you're scared, then you're fail. Yeah, I agree. I agree. Yeah, you gotta be confident for sure. I agree, 100%.
Gotta go.
Gotta sell myself. No, it's mid-level. Well, I don't know. I don't think I would even be qualified for a new grad position because like I've already have like a decent amount of years
Go, go, go.
of like actual work experience. I mean, I'd be open to the offer, but hello.
Taken out. Go, go, go.
Right.
You blink.
I feel like my game is lagging. I can't lie. 50 years is crazy. Oh wow, that is such an unlucky spray. I cannot lie.
Gotta go.
This game is fun. This game is very fun, for sure.
10 seconds until stage change.
Oh my god, why can't I kill these people? I don't understand. What are they doing?
Stage 2.
Oh my god.
Chambers looking good. Rampage.
Oh my god, I'm so ass.
Shocking. Running low. Too slow.
Ultimate orbs.
This Reyna, oh my god, peeked before me. I'm so pissed. I peeked into her. Right, I'm so bad.
I'm out of here.
New stage ends.
Bye bye.
This guy is orange as hell.
Is that from stage?
Go away. That's 3.
Oh my top frag. Maybe everyone's just good. Not as free of a game.
One less.
Oh my god, what's happening?
This way.
Charge your
Go,
ults.
go. My ult's ready. Here we go.
What is
I'm
happening,
out
bro?
of here.
What is happening?
Almost out. Go, go, go.
What is happening, bro? What is happening? Like, genuinely, what is happening?
10 seconds until stage change.
Heads up.
Final stage.
Go, go, go.
You disappoint.
Down.
Bro,
Fire in the hole. Shocking. Stay down. I'm out of here.
that was lucky as hell.
Go, go, go.
Reina is
Go, go, go.
blocking, bruh.
I suggest you move.
Smart move.
Yep, this way.
Yikes! What is that movement?
15 kills remaining.
Insane Leetcode. Do my dailies, okay? Wow, building
Get
challenge.
out of my way.
Nice.
Enemy killed. Reloading.
Nice, bro.
10 kills remaining.
You blink.
Yo, this guy is such a... This guy is high pain. That's why he's killing me. That makes sense.
5 kills remaining.
What? My ult's ready. I'm
Come
out of
on,
here.
team. How are we so bad? Our Phoenix is terrible, bro.
Go, go, go.
Alright, we're done. We're done, we're done. We're done, we're done, we're done. Alright, I'm done. Back to studying. Okay. Okay, back to studying. What were we on? Trying to finish this problem. So I was trying to figure out this second part. Okay, so the sliding window part. This part. So the balance was making sense. So like I think the left side represents -1. The right side represents 1. If at any point we remove from the left side, we would basically I think we remove from the balance.
We just took a number, so now we need to count what's going to happen to the balance. So we're going to basically go through the two cases here. So if the nums of I, so the number that we just took is actually less than or equal to the median, that means that it's going to go into the max heap because it basically will store everything to the left of the median or equal into the median. So if this is the case, then obviously we've now just added a new element to our mini heap, so we can increment the balance. And balance really just...
We increment the balance. Hold on. Because the balance, if the previous is less than the median. Oh, right, because we're adding 1. Right. Because we subtract 1 on the previous, and then on the current one, we're adding it. So that's why we add it back in. So it starts off as -1 because we took 1 out, and then we would increment it by 1 after the fact because we added it a new one to the same heap.
represents kind of the state of the max heap, because that's really what we're interested in. So we're going to increment 1 to the balance because we've now added an element to our
That makes
max heap.
sense.
So in this case, we want to then push the element onto the max heap. So we're going to push minus nums of I. Okay, so that is the case when the number gets added to the max heap. Obviously, the flip side is that we're adding it to the min heap. So in this case, the min heap will get an extra value. So now...
So then min heap is just -1, I guess. Minus equals 1.
Oh, the balance needs to get decremented by 1 because now the min heap is getting an element, which throws off potentially the balance of our max heap. So now max heap is potentially has 1 less element, and we need to take that into account. So that's why we decrement the balance here by -1.
That makes
and then we also need
sense.
to put that element onto the max heap, or the min heap, and we're going to do that now. So we add, so we're going to add number to the heap
Okay, so we just added it. So now we need to remove it.
here. Okay. Now what we need to do is take into account what is happening with our heap, right? Because our heap may not actually be balanced. So we're going to say if the balance is actually
Oh, but we got to rebalance it.
less than 0, what does this mean?
Oh,
If-
yes.
If the balance is less than 0, this means that the max heap doesn't have enough
Oh, that's true. If we do add something, I guess, well, something will always have to be balanced, though.
elements, right? So we actually need to get rid of an element from the min heap and put it onto the max heap because
If the balance is less than 0, what this means is that the previous number was less than the median, and the new number is greater than the median. So it would be -2, right? Which means that we need to move something from the right heap to the left heap.
Potentially, we got rid of an element from the max heap, and now the min heap has more elements. So we want to make sure that we actually have our balance back. So what we're going to do is we're basically going to say heap q.heap push. So we're going to push onto the max heap an element from the
Oh, frick. Can't.
min heap, basically restore the balance. So minus heap q dot heap pop of whatever is at the min heap. Okay. So that is the case when the balance is less than 0. So this is the case where the max heap needs elements. Otherwise, sorry, not else. It should be else if the balance.
So this is saying, yeah, we have to pop from the min heap because the min heap's on the right side because the right side is too many things.
It's actually greater than 0. And then that means that the max heap has too many elements. So in this case, we
The max heap has too many elements.
actually need to get rid of an element from the max heap and put it onto the min heap to balance things out. So we're going to say heap q dot heap push. So we're going to push onto the min heap whatever's at the top of the max heap, basically rebalance the elements. So we're going to say heap q dot heap pop max heap. And be careful here with the minuses because in this case we need to minus an element from min heap to basically put it on the max heap, and then here if we're putting something onto the min heap, we need to flip it from negative to positive because we're taking it from the max heap. So be very careful here because it's really easy to screw up these minus signs, and you need to be careful when working with the max heap and min heap.
Makes sense.
And then there is actually no else case because if the balance equals 0, then that means that our heap invariant
If it equals 0, everything is all in while.
is satisfied, so we don't need to do anything because the heaps are balanced based on the rules that we set, which remember are that they either have the same amount of elements or that the max heap is allowed to have at most one more element. So in that case, everything's fine. We actually don't need to do anything there. Now what we want to do is we actually need to clean up our max heap from any elements that potentially we need to remove, right? So we're storing in the heap dict elements that we need to remove. So now is the time to do this. So
Yes, now we need to actually remove prev num, no?
but while the max heap still has elements in it,
So while max heap still has stuff in it,
and heap dict of so minus max heap of 0. So basically, while the heap dict
while the heap,
has a count greater than 0 for that element
oh,
that's at the top of the max heap, we need to remove it because at this point, if it's in the heap dict, we only put the previous number. So these are all.
yeah, but how can it be greater than? How can it be greater than 1 though? I feel like this is the part I don't understand. Why is it in a while loop? Why isn't it just like a? I guess you don't know, right? Is that why?
all numbers that have already left the heap, so we just need to get rid of them, right? So we need to decrement the count of that key in our dictionary. So we do, we need to decrement the key of whatever is at the top of the max heap, and then we're just gonna pop from the top of the max heap to get rid of it. So heap q dot heap pop from the max heap. So that will clean up the max heap. Now what we need to do is also clean up the min heap, and the logic is exactly the same, but we'll just do it from the min heap. So while min heap and heap dict of min heap 0 is actually greater than 0. So while we still need to remove...
I don't understand these lines. Oh, because it's the dictionary. The dictionary just has the count of, I guess, the frequency, I guess, of that particular number. But then this dictionary, when we access it, we decrement it by 1 because we're removing it, we're popping it. But like, I don't understand why we're just popping it. This is the part I don't get. This is the part I feel like that doesn't make sense because like technically everything is sorted right now. So like if it's sorted right now, then like how do we know that we have to pop out the 1? I guess we added it to the dictionary. When did we add it to the dictionary? I forget. Num. So what? We just keep popping it until then?
Things that are still on the heap and it's at the top of the heap. Now, you may be wondering why we're only doing this for heap 0, because essentially we want to remove it when it gets to the top of the heap, because that means that we can get rid of it in constant time. If you pop from the top of the heap, you don't have to then rebalance the heap.
If you pop from the top of the heap, you don't have to rebalance the heap. Is that actually true? I don't think that's true. Because if you pop from the top of the heap, everything else still needs to bubble up.
And this is the most efficient way to do it, because if you think about it, when we calculate the median, which we'll see in a second, we're only ever using the top of the heap and the, basically the top of the heap for both of the heaps here. So we don't actually care about what other elements are in there. We're only ever working with the tops of the heap. So we don't care about the order of the other ones. We just care that the top of the heap is what we need it to be. So that's why that we want to take care that when something that should be removed from the heap actually makes it to the top of the heap, we actually get rid of it.
Max heap 1-3, min heap 4-5. You insert 5. Okay, yes, that makes sense. So even though it was sorted, you must rebalance. Wait a minute. 4-5. Oh. Oh, wait. Is this to rebalance? No, but this pop goes nowhere though. Right? Where does this pop go? This just disappears, no? Well, I guess that's what we want. But like, the thing I don't get is like, how are we guaranteed that that it's going to pop the leftmost element? That's what I don't understand. You know what I mean? Like this 1-3 -1. This makes sense, right? So we got this whatever left side 1-3, or actually -1-3, and then or -1-1, and then 3 on the right side. And then this -3 comes in, but like we add the -3 first. I believe that's how the algorithm does it. And then the left side, like, how do we know to pop the 1? Or actually, it's not even the, yeah, it's the 1. That part isn't rebalancing. That's when you actually delete. The thing I don't get is how do we know it's the 1 though? It's sorted in max heap. The left side is max heap, so like it should be -1-1, right? So if we look at heap of 0, we're asking to look at -1, or actually like this one, right? But we're not popping, we shouldn't be popping this one, we should be popping this one, no? This is the part I don't understand, because this is what I'm seeing in this while loop. Why are you sharing the right screen? What do you mean? Am I blocking it? Why am I sharing the right screen? Oh wait, I was blocking when I was I talk about the YouTube video. Hold on, let me. I just realized I was blocking when I was looking at. Let me move top. I don't know where to move myself. Am I in the middle? The thing I don't understand is like, we're looking at the 1-3 -1, right? This is our current window, and like we add the -3, right? So that all makes sense so far. But like, and I think you have to rebalance, you know, that's fine. The rebalancing makes sense, sure, whatever. And then this while loop to delete it, right? We're saying to remove the first element in the max heap, which shouldn't it be the -1? Because the max heap, because right now it's not. How do we know it's the 1 though? Like how I don't understand what we've done to know that like the top element is always going to be the leftmost element. That's the thing I don't understand. Oh, the 1 doesn't get deleted? What? Oh. Wait a minute. Wait, so you're saying that the heap is actually size 4 then, and we skip that while loop. But once the heaps are at a state where the top is what you want to delete, do as many deletions as you can. Oh, wait, so this just means, so you're saying that if it so happens to be the first element in the heap, delete it, otherwise we don't do anything? So is that what you're saying? Dude, if you didn't tell me that, I don't think I would have figured that out on my own. Is that right? So you're saying by this next iteration, we actually absorb all 4 elements. So we have -1, -3, 1, and 3. We don't actually remove the 1. That's what you say. Go back to the video? Okay.
Because as you see, the way that we calculate them, it's at the top of the heap.
All right.
Now what we want to do is we actually need to clean up our max heap from any elements that potentially we need to remove, right? Because we're storing in the heap dict
We need to potentially remove, he says.
elements that we need to remove. So now is the time to do this. So while the max heap still has elements in it, and heap dict of, so minus max heap of 0. So basically, while the heap dict has a count greater than 0.
If it just so happens, so it's just, if it so happens that our max heap has a value in the dictionary that's greater than 0, we can just delete it. That's the logic.
For that element that's at the top of the max heap, we need to remove it. Because at this point, if it's in the heap dict, we only put the previous numbers. So these are all numbers that have already left the heap. So we just need to get rid of them, right? So we need to decrement the count of that.
Oh, so this is why this is the lazy delete. He's checking that the number of requested deletions for the top of the max heap, you start deleting. Yeah, but like if we're looking at the example, right? In this case, max heap would actually be, in this case, well, what do I need to close? Okay, in this case, the max heap, which is the left side, right? It would be well, hold on. Let me write it down so I'm not confusing myself. So max heap is currently, I believe we said it was -1, 1. And then min heap is 3. So we add the -3, right? So -3 gets added to the max heap, right? So -3. Wait, am I doing this right? I might be doing this wrong. I think it's actually 1, -1, -3. Basically, both of the heaps might potentially contain dead elements, but he's separately keeping track of what the real median is. Separately. Oh, separately. Yes, because our basically. Oh, okay. Then let me ask this then. Do we even, like, is this deletion part even necessary? Oh, I guess it is actually. Wait, but that's another question I guess I would have then. Like, how does it know that we need to delete? Like, if we're not always guaranteed to delete something, right? Like, how do we always guarantee that there will never be a case that I don't know, like, how do we always know what the right numbers to look at? By using the balance variable. Yo, this is a little confusing. Can't lie. Cause like let's say hypothetically, right? what if we somehow like kept something? Like in my head, I'm like, what if we don't lazy delete? Like, what if we end up skipping the deletion for something we should have deleted, but it ends up in the median? I don't know if that's possible. I mean, obviously it's not possible. I don't understand how that. I don't know. It's a ChatGPT question. But, dude, like every time I feel like I understand this question, I end up finding more things I don't understand.
Current balance, and that is based on in heap max heap, because if deposit, so we need to decrement the count of that key in our dictionary. So we do we need to decrement the key of whatever is at the top of the max heap, and then we're just gonna pop from the top of the max heap to get rid of it. So heap q dot heap pop from the max heap. So that will clean up the max heap.
This is really funny. What do you mean?
Because if the balance...
What is this? Hold on, let me look at that. This PC. Does he even give credit? Let me see. Wait, it's the same exact solution. Okay, but who do you think? Wait, well, hold on. What came first? Let's see. Wait, this was 1 year ago. Well, actually, his submissions might have been.
Brought to you by
I actually wonder if he posted two.
Rogue.
The space...
Your logic using the balance is so confusing. What stupid logic is this? Just so confusing. Wait. Should I not do this solution then? Wait, is this solution confusing or no? Is there a better way to do this? I don't... Dude, wait. Oh my god, bro. This question is so cancer. I just want to move on. I don't know if I just want to like gamble that they don't ask me this question, but I do need to learn it. Just sorted list it. Oh my god, bro. Yo, this question is so cancer. But I'm so close to figuring this solution out though. Like, I just don't understand this last part. But I feel like everything else makes sense. Like, you know, we initialize the list with a min and max heap, right? And that'll help us keep track of the median, you know, depending on if it's even or odd. And then from that point on, we can traverse through the rest of the array. And then we got to add based on a balance. And then rebalance, I guess. It's unbalanced. But then this last part, the lazy delete part, it's the part I just feel like so jank. I'm getting hungry. Pretzels. Oh my gosh, I just no, but if I sorted lists and then the meta interviewer's like, can you do this a different way? I'd be like, I mean, I could get close to the solution, I guess. God damn.
We can get rid of it in constant time. If you pop from the top of the heap, you don't have to then rebalance the heap. And this is the most efficient way to do it, because if you think about it, when we calculate the median, which
Sure, let me ask ChatGPT. Does this dude give credit? No, he doesn't. I don't think so. I don't think he ever does. Oh, I could be wrong about that, but would this solution work with lazy delete? Oh shoot. I didn't mean to say with, I meant to say without. Would it work without lazy delete? The solution wouldn't work. It will still contain values that are no longer in the sliding window. But that's what I'm saying. That's what I don't understand. For this solution to work, it has to remove this one, no? Or sorry, not yeah, it has to remove this one. Does it not? I don't know. Now I'm confused. I don't know what to think now. Is lazy delete actually not deleting? Oh, you know what heap it's in? Okay, so you know the number you need to remove based on the dictionary, right? Okay, hold on. Okay. All right, so we know based on the dictionary. Hold up. And the dictionary stores the previous num. But that's the thing though, max heap of 0. I mean, isn't it possible that in both cases, in the max and the min heap, we don't remove the 1 after the first iteration? Like in this step. Because hold on. Actually, let me ask ChatGPT. Run through lazy delete. Here. The 1 isn't removed. So you actually know how many live elements are in each heap, which means you can change your rebalancing logic. What? GPT is crapping out. Oh my god. I don't know who to believe anymore. It's over. Alright. Let me give him the solution and make him run through it. What happens with the lazy delete? It's marked for deletion. Okay, that makes sense. All right. So conceptually, I understand that lazy deleting is saying we don't have to remove it now, but we'll remove it when the opportunity comes, right? Based on if it's in the top of the heap or not, right? But the part I don't understand, though, is how do we always know the correct, like, because if we don't delete anything, right? Our heap size is messed up, right? It's messed up because it would have 4 elements, no? Because we would add the -3 and then we keep everything else because the 1 should be marked for deletion, but it's not actually deleted yet because it's not max heap of 0. You don't have to delete anything. Wait, hold on. Let me ask ChatGPT in this case. Oh, it says I have to. Frick. Yo, I don't get it, man. While min heap negative max heap is 0. Okay, let me ask ChatGPT the same question I'm having right now. Can it? Hello. Wait.
Hey, it's
I don't understand how lazy delete works when you could potentially have, let's say, 4 elements in the heap and case equal to size 3. Please explain how it's still able to calculate the median correctly, even if we didn't delete the top of the max heap yet or min heap. Oh my god, can ChatGPT register everything I just said? Oh, that's nice. Yes. Because we only mark things for deletion, we only remove them when they reach the top of the heap. So yes, at any given time, the heap might have more, including stale values. Yes. Oh. Oh, that makes sense. Oh my god, it makes sense now. I see. Okay, so it works because even though 1 isn't deleted yet, it doesn't matter because all we care about is the 0th element of the max and the min heap. So if it's anything like under that, then it's irrelevant. That's why we don't delete it. It doesn't matter. That makes sense. Oh my god, it makes sense. I get it. Does that make sense, chat? No, but impressive. I get it. I get it now. Okay. So, to reiterate, right? So in a median, we only care about the zeroth value from the min heap and the max heap, right? Knowing that, my whole thing was I was confused as to why does it matter, like the reason why lazy delete, if we didn't lazy delete at all, the reason why it wouldn't work is because there would be cases where, you know, the max heap or the element we need to remove is actually the max, like the zeroth element of the max heap or the min heap. So if that's the case, then we'd actually, that would affect the result because we'd have to remove it. That makes sense. That makes sense. The question is cancer, though. Jesus Christ. Can I move on with my life? I just want to move on with my life.
Which you'll see in a second, we're only ever using the top of the heap and the, yeah, basically the top of the heap for both of the heaps here. So we don't actually care about what other elements are in there. We're only ever working with the tops of the heap. So we don't care about the order of the.
You actually just explained that right there, but at the later on.
We're only ever at the top of the heap. You don't have to then rebalance the heap. And this is the most efficient way to do it, because if you think about it, when we calculate the median, which you'll see in a second, we're only ever using the top of the heap and the, yeah, basically the top of the heap for both of the heaps here. So we don't actually care about what other elements are in there. We're only ever working with the tops of the heap. So we don't care about the order of the other ones. We just care that the top of the heap is what we need it to be. So that's why that we want to take care that when something that should be removed from the heap actually makes it to the top of the heap, we actually get rid of it, because as you see, the way that we calculate the median is only based on the top of the heap, or yeah, basically the top of both heaps. So the order of the other elements doesn't actually matter. Okay, that little ramble aside, let's now do the same thing. So we need to decrement the count of whatever's at the top of the min heap by 1, and then we need to pop from the min heap. So heap q dot heap pop from the min heap. Okay. Now what we need to do is simply just append the result for this case. So as you can see, we still haven't calculated the median. Now we've taken care of basically balancing the heaps, making sure that we removed an element correctly based on how the previous element was removed, and then we also added our new element, so we took that into account. Now the last thing we need to do is actually just calculate the median. So what we can do is just copy and paste this code here for calculating the median, and paste that there, fix the indenting, and then this will basically calculate the median. Again, if it's an odd k, then we just need the top of the max heap. Otherwise, we do the mathematical calculation, and we just append that to the result, and that's it. So once this for loop ends, my indentation, all we need to do is simply just return our res, and we are done. Now, tricky part, did I make a mistake coding this up? I would say yes, but let's see.
Okay. Let's code it up from scratch. All right. Not evil. I'm giving you guys content. You guys can thank me. All right. Let's do this. That's right, Moku. It's the good stuff. All right. So we want to build this heap, right? From the max heap, median, min heap, right? This way, we'll maintain, you know, the top elements of each, and also, if odd, it's just max heap. If even, max heap plus min heap divided by 2. How it's only 1200 deserves more? What do you mean 1200? So the thing that we want to do is actually first put in the max heap. So heap q dot heap push the max heap of nums of I, but negative nums of I, because we got to do negative numbers for max heaps. And then we want to do that very thing where we just push it. We pop it and push it into the min heap. Heap q dot heap push min heap. Heap q negative heap q dot heap pop max heap. Chat peak performance right here. Thank you. Wait, Costco has it? I've never seen Costco have it. What? And then from this point on, we need to rebalance, right? So if the length of the max heap is greater than length of the min heap, sorry, I think it's actually the other way around. We need to rebalance it, right? Need to add it back in to heap q dot heap push back to the max heap from heap q dot heap pop the min heap, right? I still want to like revisit why this logic works. I don't know. This is clever to me. I just feel like I would never think about doing it this way. But this is like so clever. Because like this, we say, like we start with the 1, right? Then let's say we have min heap. And then we have a max heap. Like we start with adding it to the max heap. So we add it to 1. Well, it's actually -1. We push it now to min heap. But the elegant thing, so I guess we add this back in, right? So then we get a 3. But the thing is, like, the max heap's going to keep the 3 at the top. So at all times, we're always popping the largest element and then passing it over to min heap. That's the reason why it works. So it's clever. I would never think about doing that way. It's clever. I don't know. It's clever. I would never think about doing it that way. Okay. So then once we rebalance, then what's next? I think then we check, right? If k modulo 2 is equal to 1, I think we do it outside of this for loop, right? Else, so it's odd. If it's odd, we can res append max heap of 0. Otherwise, we res append max heap of 0. Actually, it's also negative max. So lapis. Negative max heap of 0 plus min heap of 0 divided by 2. Right? So at this point, we should have hold on, let me just double check my code to make sure it makes sense so far. So we should have a 1 so far. Good. Everything is good. Everything is sound so far. So this part, all of it makes sense to me. I think. This part, I don't know if I'd memorize it. I don't know if I should memorize it. But I feel like this is just clever. Like there's this trick, this pattern is that you can use a max heap and a min heap and then basically just push to the max heap, then pop to the min heap to balance. I don't know. That's like a pattern, I guess I might just have to memorize. And then at this point, now we have to do for I in range from k to the length of nums, right? So we start at 3, right? So 0, well, k is 3. So 0, 1, 2, 3. So now we're at this -3, right? So what do you want to do with it? Also need to maintain a dictionary like we said. I guess default dict int. And then for iron range decay to the length of nums. So we want to add, right? Do we want to add the element first? I think that's what we said we were gonna do. Heap push. Oh, but we gotta check which side it's on, right? So if nums of I is less than or equal to oh, we also need to keep track of the previous num. which is equal to nums of I, is it I minus K? I think so, because I would be 3 and then K is 3, so nums of 0. So if we need to first check I have a condition? What do you mean? It's a natural reaction. It's just carbonation. You don't see me burping like this when I don't drink it. Fry and range from K to the length of nums, prev num. Okay. So, what are we checking? If nums of I is less than or equal to, what are we comparing it to? Don't we just compare it to the median? Which I think he actually didn't write until the end. Yes. Wait. Oh, yes. Yes, I was going to say this. I caught it before I even got there, which is good. Median. Wait, that's interesting. In Python, you can just declare a variable inside an if statement, and as long as you include it in both, it'll register. That's low-key nice. So median, we'll just actually say this is the median, then median, then in the same way, median is equal to this, median. You burp like every min? Because I take a sip like every min. My condition is not natural. Says who? What do you guys know? Okay, we also have to add it to the dictionary. So d of nums of I minus K plus equals 1. Mark it to be deleted. Lazy deleted in the future. If nums of I is less than or equal to the median, then this means that the number that we're adding is going to the max heap. Right? So heap q dot heap push max heap nums of I. And again, we gotta do negative because it's a max heap. Else heap q dot heap push min heap to nums of I. Now we gotta balance, or do we balance first actually? Balance is equal to -1 if, right, so we gotta balance it. So based on the previous number, based on the previous number, we're also going to be removing an element, right? So if the prev num is less than or equal to the median, else 1, right? Because we're saying that if it's less than or equal to the median, then something in the max heap gets removed, right? And then here in this case, we'll say balance plus equals 1 in this case, because the balance has been restored. And then in this case, balance minus equals 1. And then in this case, after all this, we have to consider if balance is greater than 0, else elif balance less than 0. If the balance is so let's say we have the case where -1. So if something from the left, so if something from the max heap got removed, and then something from the and then something got added to the min heap, we have to rebalance the min heap to push it to the max heap. So heap q dot heap push the max heap with the heap q dot heap pop from the min heap. And this should be the negative value. And then in this case, the opposite, right? Heap push, min heap, and then again, negative heap q dot heap pop max heap. So once we have our balance set up, then now we have to handle the lazy deletes, right? So at this point, now we'll say while what was the condition? When do we stop? Definitely one condition is while d of nums I is greater than 0 and max heap of 0 is I think we should do it the other way around, but it doesn't really matter, I guess. So while max heap of 0 is equal to the nums of I, wait, it's not nums of I. I don't wait, hold on. This don't sound right. I don't know what I'm checking. What is our exit condition? Definitely when our dictionary is going to 0. Once our dictionary is 0, we're done. But also we only want to delete. And also I don't think it's nums of I think it's prev num. Right? I've never heard that before, Moku. That sounds like a new study. Never heard that before. And no lazy deletes. Okay, what am I deleting though? It's prev num, right? Prev num. But also we d of prev num is equal to it also has to equal to the max heap of 0. And this, right? It has to satisfy these two conditions, I'm pretty sure. So we do this for the max heap and the min heap, I believe. Min heap. And then in the max heap case, we're obviously going to need to deprev num. But actually, nums of I minus k, prev num. I should have just done this. Minus equals 1. Same thing here. Minus equals 1. And then here, what we're actually going to do is heap q dot heap pop. Heap q dot heap pop the max heap. And same thing here. We're going to pop the min heap. I think, oh, and then we got to calculate the median, right? After all this. And like he said, we can just literally copy paste. I think the same exact logic we had up here. And then append it to the results. Oh. Index is out of range? Oh frick, that's what I need to check. Frick, I forgot. What do I check? Wow. Oh my god. Of course, we can't pop anything if we don't have anything. While max heap, oh my god, while max heap, I overcomplicated it. And also, is this correct? Oh. It's not prev num. Oh my god, it's the min heap. Oh my god, it's the negative max heap of 0. Holy frick. Oh my god, GG. I still got it wrong? Oh wait. Still got it wrong? What the hell is wrong? I don't care. I'm ChatGPTing it. There's got to be one small bug somehow, and I don't want to waste my time. I was gonna say I'm very close. Wait, what? Wait, it's saying it looks good. Yo, are you dumb? Oh my god. ChatGPT is trash. All right, let's find a difference, I guess. So we have min heap. It looks good to me. I want to try. All right, what happens if I tell it there's a bug though? What's it gonna say? Oh, my bad. My apologies. There's a bug though. You're right, there is a subtle bug. I forgot to negate one of them. What? Oh, frick. Oh, frick. Easy. Dude, 55 lines of code. Well, I guess including comments, but still. Oh my god. Thank you, Hilo. Dude, I'm moving on from this question. I'll come back to this question, but at least we got... I feel like I understand it, though. I finally understand it now. Jesus, I've been stuck on this problem for like 2 to 3 days. I don't even know how long. Finally, we're freaking done. Can move on with my life. I feel like I've been hard stuck. But hopefully after doing this, I feel like the other questions are easier. Dictionary plus min max heaps with lazy deletion. This question is cancer. And then time and space complexity, let's talk about it. Well, to perform a heap is always log of n time, right? And you could be theoretically doing that n log or k log n times, right? Or is it n log n? No, I think it's k log n. Because we are only maintaining a heap. Well, actually, the heap could be bigger than the size of k. So that's not even true. I guess whatever the size of the heap is. Log n.
Current balance. And that is based on just the number. So, what is the time and space complexity for our algorithm? Well, as you can see, we're really working with two heaps here, and the operations are nested for them, so they're just really gonna happen side by side. So for any heap, how many elements are in the heap at once, right? So it's gonna be n item or k items in the heap.
K items in the heap. Is that even true?
And how many times do we need to basically do all of this? You'll notice here, actually we do push things from the heap and pop things here. So really, it's like n log k for the time complexity.
N log k.
Because obviously we have k elements in the heap, and then we have,
Technically, is it not n log n? Why is it n log k? What's time and space complex? It's n log k. You're inserting k elements into the heap. Okay. Total cost per window slide. N number of times based on the window slides. But it's n minus k windows. I don't even know if that makes sense. Lazy deletion, worst case could pop multiple elements. Rebalancing, insertion, that's whatever. Do we have to explain this n minus k part? Surely not.
0, because... So, what is the time and space complexity for our algorithm? Well, as you can see, we're really working with two heaps here, and the operations are nested for them, so they're just really gonna happen side by side. So for any heap, how many elements are in the heap at once, right? So it's gonna be n item or k items in the heap, and how
K items in the heap. I don't even know if that's true necessarily, but okay, I'll assume that's true.
how many times do we need to basically do all of this heap popping? Because you'll notice here, actually we do push things from the heap and pop things here. So really, it's like n log k for the time complexity, because obviously we have k elements in the heap, and then we have n elements that we have to process in our nums. So that is going to be the time complexity here. So we have that. What else do we have for the space complexity? Well, we have the heap. We have the heap dict. So the heap dict is only going to store the k elements that we have. Actually,
The heap dict space. I think it's size k. We also stored a dictionary. Could be of size n.
no, because we cleaned up each time, so it should only store at most 3 keys, I think. But it's fine. And then we have the max heap, which obviously is going to store k elements. and the min heap, so it's like big OK plus big OK, but we know that this is just asymptotically the same as big OK because we get rid of the constant when we do it, so it's like 2K, but this is just like big OK. Okay, so yes, time complexity and log K, and the space complexity is big O of K.
Do we just ignore the dictionary then? I guess.
Okay. So
At most K keys. Okay. Okay, I guess. I don't know. Okay, sure. At most K keys. How can there... Couldn't there be more than K keys? Couldn't have more than K keys in the D? It still doesn't break the space complexity. D could have up to n minus k keys at once, because n minus k numbers might be pending deletion. Care about the auxiliary space that scales with the window, not n. It's a little confusing, I don't understand. While the theoretical max size of D is O of n, the number of keys relevant at any one time is tightly coupled to the heap size, so in practice we treat it... Okay. I guess that kind of makes sense. The heaps, max heap and min heap, each store about K divided by 2 elements of K. The number of entries in the D map at any moment is bounded by the number of still elements in the heaps. For instance, each number is inserted and removed exactly once. Total number of entries added to D over time is O of n, but only a small number are active at a time. Why is it n minus k? How is it n minus k? D is the lazy deletion map. You process n elements. The first k elements go to the initial window. Oh, I see. That's correct. Yes, that's correct. Since old elements reach the top and get cleaned quickly. Okay, I guess I should just know that. But it should be O of K because the dictionary should maintain that size as well as the heaps. So they should all be O of K. Okay. Okay then. So we have this n time n log k. In space O of k. Okay. Cool. Cool. All right. Let's see. Let us see here. Oh my god, we can move on to the next question. Finally. Finally. Wait a minute. Exclusive timeout functions. I just did this question. This question was not easy. This question was annoying from what I remember. Good thing I'll speed run all of these questions like 3 to 4 times. So we'll make sure that we get through enough. How many questions did we do so far? We did 51. So we still need to do at least 24 more. Okay. Next question. New one I've never seen before. All right. Let's lock in. Perform the following shift operations on a string. Right shift. Replace every letter with a successive letter on the English alphabet. ABC can be right shifted to BCD. Or XYZ can be right shifted to YZA. Left shift every preceding. Okay, we can keep shifting to form an endless shifting sequence. You're given an array of strings. Group together all strings that belong to the same shifting sequence. A, B, C, B, C, D, A, C, E, F. A, B, C, B, C, D. I don't understand the shift part. What's the point of the shift? Group together all strings I that belong to the same shifting sequence. A, C, E, F. It's skipping by every 2 letters? A, B, C, D, E, F. Wait, what? E, F. A, C, E, F. What does that even mean? This question is weird as frick. You guys really need to do a better job at properly describing the problem. I agree. I don't understand this question. All right, let me look. I don't know.
Hello, and welcome back to the Cracking Paying YouTube channel. Today we're solving Leetcode problem 249, group shifted strings. We can shift the string by shifting each of its letters to its successive letter. For example, ABC can be shifted to BCD. We can keep shifting the string to form a sequence. For example, we can keep shifting ABC to form the sequence ABC, BCD, XYZ. Given an array of strings, group all strings that belong to the same shifting sequence. You may return the answer in any order. Okay, that's the question prompt. We're not going to bother going over the example because this problem is so horribly written.
That's what I'm saying. I don't understand what it's saying.
And it's one of those questions that is a 0 intuition problem and a 100% memorization problem. If you've never
Okay.
seen this before, you probably won't figure it out because of how terribly this question is written. And this is just one that you memorize, and I guess you just need to be able to explain it.
Okay, cool. I guess.
So what this problem doesn't tell you is that characters will actually wrap around. So as you can see here, the characters A and Z are actually in the same shifting sequence. That one's pretty self-explanatory because they're the same character. You know, you can shift
What's up, Ritik? What am I doing? I'm just studying. I'm studying.
A one character at a time to get Z. But A, Z, and BA are also the same because if you shifted both of these by one, you get the B here, and then the Z would actually wrap around to A. So that's one thing they don't tell you, but you
Wait. Oh.
get wraparounds. Anyway, yeah, the way that you solve this problem is actually really stupid. So what you want to do is, you'll see for each one of the characters here, let's take the sequence, for example, ABC, BCD, XYZ. It's pretty easy to visually see that ABC can just turn into BCD by shifting each one of these by 1, and then so on and so forth, and you can eventually get to XYZ if you just shift each one by 1. The pattern we actually want to notice here, and the way that you're actually going to solve this, is that the difference in character position of each of the characters between each one is going to be a constant 1. The difference between B and A in the alphabet is a position of 1. The difference between C and B is also a position of 1. Same thing for B, C, D. C minus D in the alphabet. Oops, sorry. C minus B is a position of 1, and D minus C is a position of 1. So what you want to do here is, for every single one of these problems, you want to figure out what the shifting sequence is, and what we mean by that is the difference between a character and the next character in the alphabet. Now, we have to worry about wrapping around, but we'll handle that later by using the modulo operator. So modulo 26 to handle the case where we could have something like, I don't know, Z minus B or something, right? Or sorry, we could have like A minus Z, something like that, where we get a negative number, so we want to handle that. But anyway, let's not get ahead of ourselves. What we want to do is we want to iterate over all the strings from left to right, and we want to build a map where the key is the sequence, and the value is a list of all the words that fall into that sequence. So this will be words. For example, let's take A, C, E, F, right? A, C, E, F. So the difference, so we're going to build a key out of what the sequence is here. So the first item in our key, and we're going to use a list here because we need to append to it, so we can't use a string and we can't use a tuple, because obviously those are immutable. So the difference between A and C in the alphabet is going to be what? 2, right? So the first element in our key is going to be 2. Then what's the difference between E and C? So let's count it out. We have A, B, C, D, E, F. Actually,
Oh, I see.
that's all we need for this problem. So again, it's 2. So the second difference is 2. The same thing between E and F is going to be 2. So our key is actually...
Wait. What? Oh.
2. Now, if you know anything about data structures, you actually can't put a list as a key in a dictionary because the list is mutable. So you have to turn this into a tuple to basically use it. So for example, in our map...
Wait. A, C, E, F. A, B, C, D, E, F. Isn't it 2, 2, 1?
Here, we would get
Not
the
2,
key.
2. Where am I from? I'm from the US. From Mumbai? That's crazy. That's crazy. Are you also studying?
2, 2, 2, and this would contain the word A, C, E, F. And basically, we'll do this for every single character here.
This makes sense.
There's a special case if you get a character of length 1, that just belongs to a special count. Obviously, there is no difference, so we'll just put it as -1 here if it's a single character. So we'll just put A and Z in here. We can basically do this for all the characters. So let's do another example. So we have A, B, C. The key here would be what's B minus A, that's 1. What's C minus B, that's 1. So for the key 1, 1, we will essentially put, let's see, A, B, C. We can do the same for B, C, D. So we'll have, what's the difference between B and C? 1. What's the difference between D and C? 1. So now we have the same key, so we can add B, C, D, and it's the same for X, Y, and Z. And then for this case, this is the point where we actually need to handle our difference. And because if we try to compare A and Z, obviously A is index 0 for characters, or it's maybe 1, it doesn't matter, and Z is 26, so this will be negative 26. So
It feels so nice to see a data structure that's like not that complicated, because I feel like this problem is way easier than the one we just did.
because we want to work with negative numbers, because this wraps around, we actually just want to put, oops, you can't see that, that's outside of the bounds. When we have a negative case like this, we actually just do modulo 26, and that will solve it for us to handle the wraparound. And then these two will get put together. So that is the general intuition. Kind of just to summarize, we're going to go over the strings from left to right, iterating over each of them. We want to build a map which maps the sequence to each of the words in that sequence. And the way that we derive the sequence is we take each word and we compare a character starting from the first index with the last character before it, and we take the difference between the characters in the English language, right? So the position of C minus A is going to be 2, right? Because C is the third character, A is the first character, so 2. And we're going to do this successively until we build our sequence. This is going to be a list. We need to make it into a tuple to put it into our dictionary, and then we're going to insert that key, that word for that key, and then at the end, all we need to do is just return all the values here from our dictionary, and that will actually give us our answer here. So very strange problem. Like I said, if you don't see the solution before, probably not going to come up with this one, especially because they don't tell you anything about wrapping around in this question. But anyway, that's enough blabbing. Let's actually go to the code editor and type it up. The code is surprisingly simple. It's just figuring out what to do from the shape problem.
Okay, it seems not too bad. I guess just to handle the wrapping part. Oh, you're working for Comcast? Nice. That's good stuff. It's good stuff. Do you enjoy it? How is that? Okay. So we're gonna start with the okay. So we need to go through every character. And pre-chart to figure the distance. And create a dictionary of tuple keys. I guess we're gonna have to convert list to tuple because lists are mutable, right? Is that why? So in that case, I'll have a res, return res by the end of all of this. Okay, so we're gonna have to go through 4 word in strings. So we're at the current word, right? And then we're gonna have to go through The thing is, we have two cases, right? If length of word less than 2. I feel like this is more of like an edge case, right? We can just simply say we'll also maintain this dictionary like we said. If the length is less than 2, it's a single character. I mean, I'm assuming that, yeah, we can assume that there's not going to be an empty string. So if that's the case, I'm new to programming. DSA, I'm learning that you will have to explain to me this problem that you are solving where I'm used in a real life scenario. To be honest, brother, I don't think I'm ever using this in real life. But unfortunately, I didn't come up with a system. And unfortunately, this is what the system is. So what can you do? I guess you could just... I guess you could choose to, make less money by not learning it, but I don't know, dude. I agree. I think it's stupid, but what are you gonna do, you know? If you can't beat him, you have to join him. 100% agree. So if the length of the word is less than 2, then that means we can simply say D of the word. I think this will make it as tuple, right? Actually, D of 1 is equal to default to the list d1.append word. Otherwise, we're gonna handle this case where the string. Okay, I'm gonna see if this is the optimal way to do it though.
Problem description, our grouping dictionary, and this is going to be a tuple with the key -1, and that's all for that one. And obviously for that key, we just want to append our current string. Okay, otherwise we need to one. So this is a special case. We're gonna say that grouping dict for this one is simply going to be a tuple with the key -1, and that's all for that one. And obviously for that.
Why is it a key of -1? What?
Key, we just want to append our current string. Okay.
Okay, that makes no sense. But we'll move on, I guess. I'll figure out why it's wrong in the future. But so in this case, the string is going to be more than size 1. So that means we can maintain so I guess like a previous and next pointer basically. So L is equal to 0 or what do you want to call it? Prev is equal to 0 and prev is equal to 0. Cur is equal to 0 while cur is less than the length of the word. Actually, we don't need to maintain 2. We can just maintain 1, right? So cur is equal to 1. So while cur is less than the length of the word, prev is equal to cur minus 1. And at this point, we can say we're gonna have to do this for every single one, right? So we're gonna maintain a list, I think, which we're gonna initialize as, you know, distances. We'll initialize, right? So we start with the first case, A, B. So B minus A, right? So we do cur dist is equal to word of cur minus word of prev, but also we're actually going to need to do an ORD function. So I believe that's what you're supposed to use to calculate the actual value. And this should give us a value of 1. And then we can say distances.append cur dist. And then at this point, we can simply increment our pointer. Plus equals 1. And we should go to do this. And then by the end of all of this, we've created our distances array, which can we, yeah, okay, so we can convert this. So D of tuple of distances, which we're going to append the word in this case, right? And I think that should. I don't think this is going to actually work for TLE. The hell is a TLE? Cur plus equals 1. I don't know.
Otherwise, we need to compute those differences in characters. So we need a list to store those differences. So we're going to say char diffs. This is going to be an empty list. And then we want to go over our string from left to right. And we want to get the index because we need to compare to the previous index. Here, and obviously do. So we have string of I. So what the ordered function does is basically given a string, it will give you kind of the position of the string. You know, you get either 1 or 2 depending on whether it starts there. Actually, or x in a string. Shoot, that's -1. Closing it. Okay, cool. And 6 is because we want to with the negatives. We want for it
I actually don't need prev, but just for the sake of readability, I feel like it's not too bad.
to wrap around. That's why we do modulo 20. See, that should be bracket. Okay, r -1. These two will close each other. I think I'm missing one. No. Okay. What is this close? Okay, this should be closing it. Okay, cool. And then we want to just take the modulo 26.
And the reason we do modulo 26 is because we want to actually get rid of negatives when they happen. So
I want to get rid of negatives. Okay, I'm not sure if that's that intuitive, but okay.
We don't want to deal with the negatives. We want for it to wrap around, and that's why we do modulo 26. 26, obviously, there's 26 English lowercase characters. Okay, so now what we want to do is once we've appended that, obviously we want to move on to the next thing in our string here. So we move forward, and then once the while loop ends, we simply just want to add our character diff.
That simple. I mean, I guess I didn't need this pointer. Could have just, well, whatever. It doesn't matter.
Differences as the key and add whatever word we were just parsing. So we're going to say our grouping dictionary. We're going to, as the key, remember we need to set it as a tuple because you cannot have lists which are mutable as dictionary keys.
Okay, which I did.
Data structure, so that's why we're going to pass it as a tuple of our tar diffs, and then we're going to append our string here.
Did I append? Yeah, append.
And that's all we need to do. At the end, we remember that the mapping is from, we're going to have a mapping of the key to basically the list of words for that shifting sequence. And then our solution is already listed list, so we just need to return the values from our dictionary. So we're simply going to say return grouping dict dot values. Okay, let me just make
return grouping dict dot values. Where's my dictionary? Did I even? Well, I'm in the wrong question. What the hell's happening? Return d values. I actually don't even need the res. Okay, what is wrong with my code though?
make sure I didn't make any mistakes because this parentheses thing is definitely gonna mess me up. Okay, cool. Looks like I got it. That is surprising. And we remember that the mapping is from
wait a
mapping
minute.
of the key.
Okay, hold on. How am I not getting this? While cur is less than the length of the word. Curdist. Cur plus equals 1. Oh my god, it's equals plus. F me, bro. Wait, what? What happened? Oh. Wait, what the hell is this syntax? What is that? What the hell is... Okay. Okay, ChatGPT, show me what's up. It's almost perfect. It requires a trailing comma. Make it more Pythonic. Oh. Gotta make it a list. I see, because... Wait. What the freak? Because of this? Oh, I see. Because you make it -1 so it doesn't coincide with those other cases. I guess that makes sense.
Of our current string, for string, in a tuple A for that is simply going to be a tuple with the key -1, and that's all for that one. And obviously for that key, we just...
Is that obvious? I don't know if that's obvious. I mean, I guess I've never really done much with like tuples before, so... Okay. I mean, yes, in the case that like... I think the edge case is like that one we just saw. Because if we made this a 1, right? So the reason why that fails that case is because if we did make it a 1, what ends up happening is that my code would treat all of these the same. Because then A is 1, D is 1, and then BC is also 1 because the difference between... Yeah, which is wrong. We can't say 1. Maybe we could say 0. Oh, 0 doesn't work either. Right, because you can have the same letter twice as well, which is also stupid. So you gotta say -1 because that way you won't hit any edge case. Ah, that is so cringe. So cringe, so cringe.
just want to append our current string pool because you cannot where n equals number of strings is strings. Okay.
The thing I don't get is how come he doesn't need to convert it to a list? How does it work? How does it just work off rip? How come I can't submit it like this? If I had collections.default. What am I outputting in this case? What is this? So you gotta list it. Interesting. Okay, I guess. Got it. Okay, that's not too bad. It's just this like -1 case. This question's a little stupid though. Let's see. Careful of just handle single characters with a -1 as the tuple key and convert from tuples to list, from list to tuple, and return answer as a list. Not too hard of a question. Let's go through the time and space complexity of this question, which is going to be, we're going through every word, and then we also go through every character. So let's say character is C, and then the number of words is W, I guess time complexity would be O of WC, right? And then space is basically the size of the input, which is just basically O of N. That's what I would assume.
Okay, but inside of the loop, what are we doing? Well, in the worst case, they're all going to be of length k. So we're going to have to
Yep.
do n times process n characters. So that is why our time complexity is big O of n.
If in this case it's O of N times K, then it's just O of N for space.
Definitely big O of n because we're storing each of these keys. And let's see, for each of the strings, we are creating a data. Okay, no, so it's n times k. So for each of the strings, we basically
Wait.
need to create the char diffs, and then we also need to basically cast it to a tuple. So it's also n times k.
It's also N times K? What? It's both. We need to store all the strings plus their hash values. That's true. We need to store all the strings as well as the values.
Because we have is big O of n times k. For the space and but because actually no, hold on. I think actually it's just n big O of n plus k. Let's see. Well, we definitely have big O of n because we're storing each of these keys. And let's see. For each of the strings, we are creating a data. Okay, no, so it's n times k. So for each of the strings, we basically need to create this char diffs, and then we also need to basically cast it to a tuple. So it's also n.
We need to char diffs and cast the tuple.
Times k. Because we have to create all those extra data structures for here. So that, let's see. Well, we definitely have big O of n because we're storing each of these keys. And let's see. For each of the strings, we are creating a data structure. Okay, no, so it's n times k. So for each of the
for every string, we create another data structure. That's why. Yeah. Guess that's the intuition. Interesting. Group shifted strings done. Insert into a sorted circular linked list. Don't tell me. I didn't even look at this question. Is it a binary search cycle type question? Oh my god. Given a circular linked list node, which is sorted in non-descending order, write a function to insert a value into the list such that it remains a sorted circular list. The given node can be a reference to any single node and may not necessarily be the smallest value. If there are multiple suitable places for insertion, you may choose any place. After the insertion, the circular list must remain sorted. If the list is empty, the given node is null. You should create a new circular list and return the reference to that single node. Otherwise, you should return the originally given node. So, we are given 3, 4, 1, 2. Or it's 3, 4, 1, and then we have to add 2. So, oh wait, it's not a binary search, I guess. I think you just do it. Can you do this in O of n time? I feel like this is not too hard, is it not? So I guess we could handle the edge case. If not head, then return the node of insert val.val. Now, in any other case, we have to start at the head, which is 3, 4, 1, insert 2. So we start at the head, right? The hard part of this question is maybe, I don't know, is it a 2 pass maybe? I feel like the naive solution would just be to go linearly. I don't even know if that's naive. Maybe it's optimal. Just start at the 3, right? Then you go to the 4, then you go to the 1. The thing is, like, you're in a non-descending order, right? So the moment something has descended, that means that we're starting from the beginning, right? The thing is, I think we need to maintain a pointer, right? Because it just has to be in between the two. I think that's the solution. Because let's say we had, because like from a single pointer, there's no way to know. But if we always had 2 pointers, or yeah, like two, or the references with the previous and the current, our current would be 3, or I guess maybe previous would be ahead and the next would be 4. We check if the insert val is in between. Oh wait, that doesn't work. Frick. Maybe the first pass, actually. The first pass, you just figure out when does the thing decrease, right? Because if we find a node that decreased, it's either we start at the first position or we start in the middle position, right? Because in this case, we start in the middle position. We don't know where the start is. So then we go to the start, and then from the start, then we do the check, is 1 in between 1 and 3, right? And it is, so then we insert that val. I think that's the solution right there. So why don't we code that up? So like I said, first pass is to figure out the first decreasing element. This marks the spot. If we don't find a decreasing element, the first element is the start. So while cur is equal to head. So while cur, and also we'll maintain maybe like found start. Let's initialize it to false, right? So if at any point and then prev is equal to, let's say, actually, we will always find a start, I think. We can just return that. So starting node is equal to how do we code this? So while current feel like we need a previous to, but I don't think so. I think we just look ahead. I don't think there's anything wrong with looking ahead, right? So we'll say if cur.val is less than cur.next.val, then actually there might not be. Actually, is there a cycle? There's the number of nodes is either 0, 5, so it could just be one thing, right? If it's just one thing, if cur.next and cur.val is less than cur.next, then cur is equal to cur.next, no? So this is saying that if we have a next, so if we're at this 3, we have a next, and cur.val is less than, then we have to keep going. So now we're at this 4, and then we do the same thing. Do we check again? Is 4 okay, so actually we stop early, right? So in this case, we were at the 4, we find the 1. So if we find the 1, then we cut the loop here. So our head is currently set to be at this point. So cur.val is not less than. Then we say cur is equal to cur.next. This is our starting point, right? And then at this point, we check if so while cur, if if cur.next and cur.val is, or if insert val, cur.val is less than or equal to, and insert val.val is less than or equal to cur.next.val, then we can insert it here, right? Cur.next is, we need to temp cur.next. Cur.next is equal to insert val. Insert val.next is equal to cur.next. Temp. Right? So if we're saying at this point, we will insert it here. So we say cur.next, we store this because this originally points to 3. Yes, we hold the 3. We're saying cur.next is now pointing to insert val, which we just inserted, and then insert.next is now pointing to temp. And then we can return, at this point we can return head, I guess. Is that right? Should create a new single circular list. Return that reference to the single node. Temp is equal to cur.next. Cur.next is equal to insert val. Insert val.next temp. So what happens if we don't find anything? If we don't find, if there is no cur.next, like if there was a single element in this would fail. So actually I think we should do this outside the while loop and only get in we should exit the while loop once we found the condition, right? And Walker and I think we do all this. What's that emote? I think this I'm probably infinitely hanging somewhere. GG. GG. I don't know. I don't know if I was on the right track. I feel like it was a good try. Can't lie.
Invented. Reinvented. Invented.
Reinvented! And welcome back to the Cracking Thing channel. Today we're going to be solving Leetcode problem 708, insert into circular linked list. Before we get into the question, you guys know the drill. Please subscribe to the channel. Just sort val into be a ref in circuit. May choose any sorted, i.e. particularly. Otherwise, we're given this node, given this two main insertions happening here to three sorted circuit. Well, I mean, if we're looking at a kind of diagram, it's very easy to figure out where. So in order to do that, I'm actually going to wipe away a lot of this text to give us how we can navigate it. All right, let's think about all the possible ways that we can insert this node. So we read the question prompts, and I told you that the first case is null, right? A new node, we just have to create it itself. Is that we insert? So this, if we go back to our example where is that linked list. So this, if we go back to our example where we had the linked list sorted basically between 1 and 2. So we basically find the point where it would go into, and this is basically just going to be a point where we have a gap here that we can insert it into. So that's the second case where we basically extend the insertion value, and it's also less than the next value in the linked list, right? So in this case, if we were at 3, and there we go, is going to be one of the more complicated cases. And kind of let's redraw our diagram here, and we have these 3 nodes, and it's linked like this, right? And in the more complicated case, the insertion can happen at the end, right? So if we're asked to insert the 9, then we would have to insert it, between the 1 and the 4. So we need to account for that, because if we're just looking for a case like this, we're gonna miss it, right?
Oh, jeez. That's true. Fudge.
It's an easy insertion, but what happens when it happens at the edge, right? Or if we want to insert 0 in here, right? It would still happen between the 4 and the 1, but we can't look for this check here. So we need to check whether or not we're actually at the end. And remember, since the list is given to us sorted, we know we're at the end because our current value compared to the next value will always be greater, right? That's the point where our linked list drops off and becomes circular, right? So the 1 is basically the smallest element, and the 4 is the greatest element. When we see that drop off, so basically the current value is greater than the next value in the linked list, then we know that we actually hit the end, and now we've wrapped around to the smallest value, and our current value is actually the largest one. So in the case where we wanted to insert the 9, we would have to say, okay,
This question's harder.
4 points to the 9, and then all the 9 points to the 1. Or in the opposite case, the same way we could point to the 0, which now points to the 1, and then continuing onwards for both cases. So those are your 3 cases. So this is edge insertion, edge insertion. So those are the 3 cases that we want to take care of, right? The first is that the head is actually null. The second one is just like a standard insertion into the linked list. This is really easy. We just look for a point where the previous value is less than the insertion value, which is less than whatever our current node's value is. Also quite easy. The third case is going to be the edge insertion, and that's a little bit more complicated because we have to identify where the edge actually is that we start wrapping around. And actually,
I just realized there's a 4th case
where the entire circular
linked list is actually the same value. So if we want to do like 3, 3, 3, then we have to be a little bit careful here and figure out where to actually insert the value. In this case, it shouldn't really matter. If the entire thing is actually the same, then we can insert it wherever we want, and we will maintain our sorted order. So this is going to be a uni-value linked list, right? Where
If it's all the same, I feel like would be caught by case number 2.
all the elements are the same, it doesn't matter. So if we're asked to insert 2, we can insert it here, and that would be fine. We can insert it here, that could be fine. It doesn't matter. Wherever we insert it, we will maintain our sorted order. So we don't have to worry about if it's uni-value. We can just put that element wherever we want. Okay, so those are our 4 cases, and this is really what this question is kind of boiling down to. Can you identify these 4 cases and handle them in your code? Otherwise, it's actually really straightforward once you figure out these 4 cases and how to handle them. So what we're going to do now is we're going to go to the code editor and type this up. It's only about 25 lines of code, not too complex. The logic is pretty
Only 25 lines. Okay.
easy to follow. So I will see you back in the code editor, and we will type this up together. All right, let's go. We're in the code editor. Let's write this up. Remember, the first case that we need to take care of is that this head given to us is actually null. If it's null, then we need to create a node and actually link to say we need to link head dot next. Done. We can simply return the new head. All right, cool. Now what we want to do is actually go to our
Head.next is equal to new head. Oh, it's just pointing to itself. Oh, I see. Bakamitai. Dame yo, dame nada yo. I can't do this actually.
linked list. So typically when we go to our linked list, we have some sort of sentinel value. And in this case, we need that because we actually need to figure out when we made one full rotation, right? If we do a while loop and go to the end of our linked list, well, it's circular, so we're just going to be iterating forever. We need to actually figure out when we've done one full rotation. So to do that, we're actually going to create a copy of our head and just point it equals cur, and we'll use cur to actually iterate through our linked list here. And when the value of cur actually equals to head, then we know that we have actually done our full rotation, and we can stop there. Otherwise, we're just going to go in circles for all eternity. So we're going to say while cur.next does not equal to head. So while we haven't completed our full iteration through the linked list,
we need to do some work here. So the first case we want to take care of
is the actual insertion, right? And this is a standard insertion, so say we had the values
What?
like 1 and 3, and we were asked to insert 2, we would basically need to check for this simple case. So what we're going to do is we're going to say if cur.val is less than or equal to insert val, which is less than or equal to cur.next.val, then we can actually insert the value between cur and cur.
That's true. I don't need to know the start. I guess I overcomplicated it. I guess this is all unnecessary. God damn it, I'm trash. Well, F me then, I guess. Well, cur.
Next. So we need to create the new node that we're going to insert, and we're going to say it's going to be a node with value insert val, and its next value is going to be whatever the next node is, cur.next. And now we need to actually update the current node, its next, right? Because its next value is pointing to whatever cur.next is, but we need it to be pointing to this new node now that we created it, and we're going to be inserting it there. So we're going to say cur.next equals to new node, and at this point we've completed the lift and we've gone over it. So we have to handle what happens at the edge of our linked list, and what's going to be a node with value insert val, and its next value is going to be whatever the next node is, cur.next. And now we need to actually update the current node, its next, right? Because its next value is pointing to whatever cur.next is, but we need it to be pointing to this new node now that we created it, and we're going to be inserting it there. So we're going to say cur.next equals to new node, and at this point we've completed our insertion, so we can simply return the head, which is remember what they're actually looking for. All right, now we have the other case where we need to handle what happens at the edge of our linked list and whether or not we need to insert something there. So remember that we know that we're at the edge if the current value of our node is actually greater than cur.next.val, right? Because it's circular, therefore when we hit the end of it, the next node is going to be the smallest node. And since it's in sorted order, if we ever get to a point where small value need to instance at the edge and the head, which is remember what they're actually looking for. All right, now we have the other case where we need to handle what happens at the edge of our linked list and whether or not we need to insert something there. So remember that we know that we're at the edge if the current value of our node is actually greater than cur.next.val, right? Because it's circular, therefore when we hit the end of it, the next node is going to be the smallest node. And since it's in sorted order, if we ever get to a point where a current node's value is greater than the next node, that means that we've hit that cliff and we've gone over it. So we have basically gone back to the beginning. So we do that by checking whether or not the current value is greater than the next value. And if it is, then we need to check whether or not we need to insert at the end. So we're going to say if insert val is actually greater than or equal to cur.val, which implies that we want to insert it at the very end for the case that our insert value is actually greater than the last element, or the greatest one that we have, or the case where insert value is actually less than the smallest element that's currently present in our linked list. So we're going to say cur.next.val. So in either of these cases, we want to insert our new node at the end, and doing this is going to be the same process as we just did above. We're going to say new node equals to node, and it's going to have value insert val, and its next value is going to be whatever cur.next is. And again, we need to set cur.next now to be new node, and at this point we just want to return the head. Cool. So if neither of these statements fires here, whoops, I think this actually needs to be indented. Yeah, there we go. Okay, cool. If neither of these triggers, then, well, even if they trigger, actually no, we would return head here. So if neither of them trigger, we need to move on to the next element in our linked list. So we're going to say cur equals to cur.next, and we're going to move our iteration forward. All right, so either we're going to return in here or we're not. And what it means if we haven't returned anything in the actual process of our while loop is case number 4, in which case all of the values in our linked list are actually the same. In this case, we can literally insert that new node anywhere and we'll maintain our sorted order because the entire thing is unique value, right? So it doesn't matter if we have all 3s and we're asked to insert a 2, we can put it here, 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 it doesn't matter because that will basically be the new smallest element and it's going to be fine. So if it's all the same value, we can insert that node anywhere, which is what we're going to do now. Okay, so let's make sure I'm in.
If they're all the same.
Entered correctly here, and we're going to again say new node is going to be node of insert val, and then we're going to set the next one as cur.next, and remember that cur.next now equals to new node, and then all we have to do is just return our head here.
This question's not as easy as I thought. Must be an easier way to do this, no? Maybe not. This one doesn't look that hard. for the reasons of having 2 pointers. No way you could figure this out in an interview. There's no way. There's no way. No way. The head is equal to none. Have I really been studying for like 4 hours? Can you explain the question? I don't know the answer yet, but I did not play Valo for half the time. Come on now. That is straight up cap. Maybe like 1 hour of the 4 or 5 hours I've been studying or alive. That is cap. But I mean, basically though, the solution is that you just have to handle all the cases, I guess, which is not that intuitive, I feel like, to think about it. Because there's like 3 cases apparently. One case is that it actually falls between, you know, 2 of the numbers or 2 nodes. In which case, you know, like for example, you check, is it between 3 and 4? Is it between 4 and 1? Is it between 1 and 3? In this case, it is between 1 and 3. You just gotta insert in a position. It's still sorted. Correct. However, there's still like edge cases which I feel like aren't intuitive to come up with. Like for example, if it's all like 3s, if the numbers were all the same, then actually in that case you would never trigger. You should never trigger that condition, I guess, of adding it in, because you could have like insert a 2 in a sea of 3s, right? Like if you only had 3s and you need to insert a 2, I guess you're supposed to handle that edge case at the end. And then what's the other case? Case 2 is where it could be at the end, right? For example, if you wanted to add like a 9, right? It would never hit the first case because, right, 9 would fall outside of the range of all of these. However, in the case that because we know from a sorted list, we know what the start is, because at any point, I think the reasoning is that when you start and then traverse through, the moment you encounter a decreasing element, you know that's the start. So you're gonna have to add it in between, I guess, like this position, this 4 and the 1, which I feel like makes sense in hindsight, but I don't think I would have ever came up with that in an interview setting. I'm not sure. Which would I would have just been screwed, low key. But if the insert val is greater, so else pre-val. You can have 2 pointers. Yes, I believe that is. the only solution? I guess, yeah, that is the only way to do it. I mean, I don't think setting up the pointers is hard. It's really just figuring out the edge cases is what's hard about this problem. Hmm. Is this solution better though? Cur is equal to head while cur dot next is not equal to head. If cur val. Low-key, this solution is clean. So this one is saying cur is equal to head while cur next is not equal to head. If the current val is if it's in between, then break. Because I guess at any point we're just trying to figure out where the pointer should stop. If cur val is greater than cur next val and and cur val is less than or equal to the entered val. There's only 3 cases. The edge, normal, and that's it? It's only those 3? Why does the video I watched say there's 4 cases? Yeah, how does this solution actually handle numbers all the same? Oh, I guess in any case, you'll just add it anyways. Yeah, I guess this will handle naturally the 4th case. Is clever. I think I should probably sleep on this one. I mean, it kind of makes sense. Oh my god, yo, Figma. It's over, bro. My Figma money is over. Or is it just time to double down? Yo, I gotta buy some Figma. Holy crap. What's up, Siraj? Less than or equal to or greater than or equal to... Wait, what? For equal nums? What do you mean? How am I? I'm not doing too bad. How about you?
Then we need to check whether or not we need to insert it again. So we're going to say if insert val is actually greater than or equal to cur.val, which implies that we want to insert it at the very end for the case that our insert value is actually greater than the last element, or the greatest one that we have, or the case where insert val is actually less than the smallest element that's currently
He's L-ifing on the while.
present in our link list. So we're going to say cur.nextval, new node, either we're going to return in here or we're not. And what it means if we haven't returned anything in the actual process
Oh wait,
file
no, he's not.
loop is case number 4, in which case all of the and it's going to be fine. So syntax errors was an issue with the index. All we have to do is just return our head here.
Actually, this is similar. The solution is similar, no? Hey, it does the same thing, I think. I think the solution is the same.
Have the other case where we need to handle what happens at the edge. So say we have the values like 1 and 3 and we're asked to insert 2, we would basically need to check for this simple case. So what we're going to do is we're going to say if cur.val is less than or equal to insert val, which is less than or equal to cur.next.val, then we can actually insert the value between cur and cur.next. So we need to create a new node that we're going to insert, and we're going to say it's going to be a node with value insert val, and its next value is going to be whatever the next node is, cur.next. And now we need to actually update the current node, its next, right? Because its next value is pointing to whatever cur.next is, but we need it to be pointing to this new node now that we've created it, and we're going to be inserting it there. So we're going to say cur.next equals to new node, and at this point we've completed our insertion, so we can simply return the head, which is remember what they're actually looking for. All right, now we have the other case where we need to handle what happens at the edge of our linked list and whether or not we need to insert something there. So remember that we know that we're at the edge if the current value of our node is actually greater than cur.next.val, right? Because it's circular. Therefore, when we hit the end of it, the next node is going to be the smallest node. And since it's in sorted order, if we ever get to a point where the current node's value is greater than the next node, that means that we've hit that cliff and we've gone over it. So we have basically gone back to the beginning. So we do that by checking whether or not the current value is greater than the next value. And if it is, then we need to check whether or not we need to insert it again. So we're going to say if insert val is actually greater than or equal to cur.val, which implies that we want to
If current val is great, okay, so this means that we're like at the edge point, right? So if we're at an edge point, then we need to check if the insert val is greater than or equal to the current or less than or equal to the next, right? Is
insert
that
it at the very end for the case that our insert value is actually greater than the last element, or the greatest one that we have, or the case where insert val is actually less than the smallest element that's currently present in our linked list. So we're going to say cur.next.val. So in either of these cases, we want to insert our new node at the end, and doing this is going to be the same process as we just did above. We're going to say new node equals to node, and it's going to have value of insert val. And
yeah, this question's not too bad. It's not too bad. Should I do more should I just play some more Valorant, low key? Well, they changed the UI a little bit. It's a little bit separated now. The battle pass ends in 14 days, and I'm still not that close. I might have to do some brain dead Swifties. I'm just gonna autopilot Swifties. Like, I'm not even gonna care. I'm just like not even gonna try. Just gonna low volume and just chill. Just play casually.
Match found.
All right, pretty good session today. To be honest, I didn't get through too many questions. This question took me a long time to understand, but to be fair, I think it's a new pattern I've never seen before. And there's kind of a lot of steps to it, but you know, thankfully I understand it now. So when I come back to it, it'll definitely be easier to do in the future. Just see design tic-tac-toe and binary tree path sum. Variant of LRU cache and LCA binary tree with parent pointer. E4 verbal confirmation. GG. Dude, LRU cache is so that's also kind of an annoying question, but it's not too bad, I guess. Totally unprepared interviewer for coding. Coding round 1 passed. Coding round 2 got an easy Toplitz matrix. Solved it in about 2 minutes. Oh my god, I gotta study some systems design stuff before I go to bed.
I'm out of here. Gotta go. Running low. Neutralized. Gotta go.
What are they doing?
Enemy spotted mid.
Use tiles. He's mid now, no?
I'm out of here. Go, go, go.
Aw, thought you'd try harder.
Hmm.
I remember that one.
Gotta go. Go, go, go.
Enemy spotted. B.
Almost out.
Nice. Point out that if you initialize them, I don't know, these questions. I should watch some systems design stuff.
If you click play on this video,
Oh my god, how to prepare. It's perfect. It's literally
Go, go.
perfect.
I'm out of here. Kick them out. I don't do visitors. Gotta go.
It's okay.
Last player standing.
What?
The future of work is a career that grows with you.
I have prepared Thomas's breakfast for you to say at the beginning.
Thanks, Tom. Okay, our English muffins from England.
if you click play on this video, then you probably have an interview coming up. My guess is that you feel good about how to prepare coding interviews, but system design makes you a little nervous. I'm Evan. I'm a former staff engineer and I've conducted many hundreds of interviews. And I'm now the co-founder of Hello Interview. Hello Interview is a platform that helps candidates just like you prepare for their upcoming interviews. In this role, I've now worked with hundreds of thousands of candidates, and through that, I've gained a really good understanding of what works and what doesn't. And so I know that system design can feel incredibly overwhelming, but it doesn't.
Systems design.
Go, go, go. Gotta go.
I'm here to stay.
The hunt begins. Joke's over. You're dead.
I'm out of here.
Scatter.
Spike down B.
Go, go, go.
Last player standing.
Out of charges.
One enemy
Don't trade.
remaining.
I'm out of here.
Mmm.
Try that again. I dare you.
Mmm.
Switching sides.
The hell is that Sky doing disrespecting me like that?
Neon, leave gotta go.
Blue light filter as well.
Go, go, go. I'm out of here.
I'm going to tell you exactly which problems I would focus on in what order a little bit later on in this video, but before diving into specific questions, you need a basic foundation. And so the first thing I'll do is I'll understand what the hell a system design interview actually is. Then I'll go ahead and refresh on my fundamentals. These are going to be concepts that you likely learned back in college. I just need to touch up. From here, I get familiar with the basic components that are present in almost every single system design, and then we can finally start to work backwards from those common problems so we can build a deeper understanding. Now, you'll probably know the strategy mirrors how you're already preparing for coding interviews, identifying patterns across problems rather than memorizing random solutions. Let me show you when. So first off, what is a system design review? Well, a system design review evaluates your ability to architect complex.
Enemy spotted mid.
Gotta go.
Can I get a heal sage?
For you.
Thank
Go,
you.
go, go.
My goats. My goats.
I got spot running low. I'm out of here. Shortcut.
Enemy spotted A.
Gotta go.
One enemy remaining.
He's mid, bruh.
Spike, go, go, go. I'm out of here. Go, go, go. Healing you.
I know what that
I'm
omen
outta
is
here.
capable of. And it's not.
My game looks so yellow, I know. It's because it's my computer telling me that it's time to go to bed.
I'm out of here.
That's why. So I gotta have my blue light filter off.
Gotta go. Go, go, go.
Get this millionaire out of here? What do you mean?
Gotta go.
Spike dropped.
Gotta go. Shortcut.
Last player standing.
It's over, bro. Teammates are so ass.
Snack time. I'm out of here.
Barb, only brought enough for me.
Gotta go.
Turn off the blue filter? No.
Scalable systems to solve real world problems. Sounds like something out of a textbook. What is it really? You come to a whiteboard, you have your recipe design system, something like Ticketmaster or Uber, and you draw boxes explaining at a high level what services and interactions are necessary to pull off designing the system. In writing code, typically just boxes and arrows. Now, this diagram shows there are a few types of heavily overlapping design areas. In this video, we're talking about by far the most common, which are product and infra design problems. Now, a product problem, this is when you're designing an app or a website that you use every day, something like Dropbox or Uber, Netflix, all these things that you know well.
I'm getting an infrastructure design problem. That's what I've been told.
Enemy spotted B. Be at peace.
Go, go, go. Shortcut. Go, go, go.
Satisfied.
One enemy remaining.
Beautiful team.
Wall raised.
Gonna flash?
I'm out of here. Down. Boy, found you.
Infra, on the other hand, infrastructure design problems, these are non-user facing systems. So components like designing a rate limiter, maybe designing a
Match
message queue, or
point.
even data processing pipelines. things like
Listen
that.
up. Kill
I'm
them
probably
before
gonna
they
ask
kill
something
us.
like this.
Got gear. But in general, when you have a system design interview, it's likely to come out of one of these two buckets, product design or infrastructure design. When you get into an interview, it's really, really, really important that you follow a framework. Just keep you focused and make sure that you're on time.
Yeah, 100%. Gotta have a framework,
I'm out of here.
a template I go by.
Gotta go.
I love this sport.
I'm out of here.
What's up, Jay?
Spike dropped. I got the spike.
The hunt begins.
You numpty.
I've got your trail.
Jesus freaking Christ. Just got jump scared out of my mind. Please kill that guy and res me. For the love of God.
Spotted mid.
I feel like the Omen's still there.
My ultimate is ready.
Where the hell did Omen go? Oh, please. Oh, no. Please kill this guy for me.
Last player
No.
standing.
No.
And so as you prepare your framework for development, a strong weapon is this framework here. We're going to do your start to master device. Take it after. You're going to start by outlining requirements. Now, include both functional requirements.
Requirements, core entities, API, data flow, high-level
And the
design.
non-functional requirements. Functional requirements are just the features of the system. A user should be able to book a ticket. And a non-functional requirement is the quality of the system. Like booking tickets should be low latency. The system should be able to scale to whatever.
Sudden death.
Gotta go.
You know, I could just outlive them.
Go, go, go.
I take an ADHD test. I don't think I have ADHD.
Go, go, go.
Maybe I do. I don't know, but I don't think I do.
I'm out of here. Gotta go.
All right, I'm avoiding Omen. This guy's hella cringe.
Go, go, go.
This ensures up front that you and your interviewer agree on what you're going to be designing. Next, you want to outline the core entities of the system. These typically map directly to the tables in your database. These are just the entities that your system will persist and that your API will use. So think like a user, an event, a ticket, simple as that. Then you're going to outline the basic APIs needed to meet. Your system should be able to work well for you. I strongly recommend that you choose this framework here. What you're going to do when you restart.
Oh, I did 146 on that Omen. Makes sense. That makes sense, bro. GG.
Spike down
Start
B.
with the design system. Design take master. You're going to start by outlining the requirements of the system. Now, this includes both the functional requirements and the non-functional requirements. Functional requirements are just the features of the system that a user should be able to book a ticket. And a non-functional requirement is the quality of the system. Like booking tickets should be low latency. Right? The system should be able to scale to whatever number of users. This ensures up front.
Last player standing.
Next, you want to outline the core entities of the system. These typically map directly to the tables in your database. These are just the entities that your system will persist and your API will use. So things like user, an event, a ticket, simple as that. Then you're outlining the basic
Defenders
API.
win.
9 times out of 10, you probably do REST endpoints, but there might be unique cases where GraphQL or something else makes more sense. But from here, you then where GraphQL, and these are probably going to be REST endpoints, but there might be unique cases where GraphQL or something else makes more sense. But from here, you then get into the fun stuff. You head over to that whiteboard, you're going to start drawing boxes and arrows, starting with a really simple high-level design, where the goal of the high-level design is to meet the functional requirements of your system. So a really simple, not complex design that can allow users to say, book a ticket. From here, you're going to get deep. And this is where you're going to enhance that initial high-level design via deep dives. Where the goal of the deep dives are to satisfy your non-functional requirements. So now that I can book a ticket, how do I make sure the booking is low latency? How do I make sure that it's strongly consistent? How do I make sure that it can scale to the scale numbers that you might agree upon with your interviewer? Now, the last step in understanding what system design interview is understanding how your interviewer is going to be evaluating you. Now, every company is slightly different, of course, but they all evaluate you on some permutation of the following. 1, your problem-solving skills. So this is most importantly your ability to recognize and prioritize the core challenges of the system. So if you're designing Ticketmaster, you're focused on the booking flow, you're not focused on authentication, for example. Next is your solution design. This is your high-level design from that framework that we showed just a moment ago. You make trade-offs and you arrive at something that meets those functional requirements. Next is your technical excellence, and this is where you're going to show off in your deep dives that you have technical expertise in some, not all, but in some areas of the system. And you go deep, talk about specific technologies, talk about specific areas where things could break, all of this. And then last, of course, is your communication skills. Can you clearly explain complex technical concepts? You'll be talking for 35 minutes to an hour in a system design interview. You need to be clear and competent in doing so. Next up, you're going to make sure you have at least a basic foundational understanding of some of the fundamentals. And so people are going to provide these long, overwhelming lists. You've probably seen them online, all these things that you need to know. But in reality, knowing these 6 concepts here are going to get you 90+% of the way there. And so this is where I would focus my time. First up is storage fundamentals. When it comes to storage, you should be able to discuss various data storage models and the appropriate use cases. And so be prepared to explain things like how data is organized in a relational database, where you have normalized tables with relationships, versus document stores, where you have nested JSON-like structures, like this, and then also key value stores, where you have a simple lookup mechanism based on a key. Your interviewer is also going to expect that you understand ACID properties for transactional systems in particular, and that you're able to compare and contrast these with base principles for distributed databases. You should be able to articulate when each storage paradigm makes sense based on access patterns and the given consistency requirements of your system, which you probably agreed upon in your non-functional requirements. Now, next up when it comes to the fundamentals is scalability. And scalability is just the concept of how do we scale our system so that we can support more users and more requests. And scalability almost always comes up in a system design interview.
adobo?
And so when you're talking about scaling...
welcome. Go, go, go. I'm out of here. Gotta go. I'm out of here.
In compute, when you're scaling you should be able to have some of the concepts here are going to get you 90+% of the way there. And so this is where I would focus my time. First up is storage fundamentals. When it comes to storage, you should be able to discuss various data storage models and the appropriate use cases. And so be prepared to explain things like how data is organized in a relational data.
One suppressed.
Target spotted.
Where you have normalized tables with relationships versus document stores, where you have nested JSON-like structures like this, and then also key value stores, where you have a simple lookup mechanism. You should be able to discuss various data storage models and the appropriate use cases. And so be prepared to explain things like how data is organized in a relational database, where you have normalized tables with relationships versus document stores, where you have nested JSON-like structures like this, and then also key value stores, where you have a simple lookup mechanism based on a key. Your interviewer is also going to expect that you understand ACID properties for transactional systems in particular, and that you're able to compare and contrast these with base principles for distributed databases. You should be able to articulate when each storage paradigm makes sense based on access patterns and the given consistency requirements of your system, which you probably agree upon in your non-functional requirements. Now, next one comes to fundamentals is scalability. And scalability is just a concept of how we scale our system so that we can support more users and more requests. And scalability almost always comes up in a system design review. So when you're talking about scaling compute, when you're scaling your servers, you should know about vertical scaling, beefier machines, more CPU, more RAM. Now, so horizontal.
Vertical scaling means upgrading. Horizontal means redundancy, basically.
Go, go, go! Gotta go! Move! Go, go, go!
Take flight. Enemy tagged.
I'm out of here!
On target.
Our spike's down!
Spike down A.
I got spike.
Last player standing.
Also scaling. Let's just add more machines to be able to service these incoming requests. You should also understand how to scale storage. And so this is techniques like partitioning and sharding, splitting data instead of on a single database across multiple
Sharding.
database instances. As well as how to distribute data efficiently across these different instances, like the famous consistent hashing algorithm. We actually have a video on the channel that goes into detail on consistent hashing, so if that's new to you, check it out now. Okay, so next up is networking. When it comes to networking, you probably remember learning.
Oh my god, I'm barely bought on time.
I'm out of here!
Ah, it's fine.
Learning about these OSI layers, in college. And I have good news for you. When it comes to interviews, you only really need to know 3 of them: the application layer, transport layer, and network layer. And so the application layer is going to be the most important for your interviews. And this is where you are going to want to know things like API design, REST versus GraphQL versus gRPC, which makes sense when. And you also want to understand real-time communication via WebSockets or server-side events. This is what you'll use in the case of designing, for example, a chat app. And then second is the transport layer. And so for infra-style interviews in particular, knowing about TCP versus UDP, for example, and the request lifecycle is going to be really important. And then lastly, when it comes to the network layer, you should have some basic understanding, at least of load balancing, and maybe understand firewalls or access control lists. But unless it's a specific type of interview, this is going to be less likely to come up. Now, just like consistent hashing, we have a really excellent detailed video on all things networking essentials. And so if you don't have this already down, that's the first thing I would do. Never have you check it out. Fourth is latent.
Network extension. Dude, I should watch all this stuff. This is good stuff. Oh, he's got some good stuff.
See throughput and performance. And so there's a decent chance that you're going to be tasked with optimizing performance somewhere in your interview. And so you should be able to recall.
Go, go, go!
Networking layers? Yeah, Jesus. It's too sweaty.
All approximate latency numbers for common
Too
operations,
sweaty.
things like memory access, disk reads, or network calls. And then when discussing your requirements in the beginning of the interview, you're going to want to demonstrate your ability to understand some throughput limitations and maybe perform some basic capacity.
Gotta go! Throwing net!
Target spotted mid. Pull them to.
Standing ahead.
Come back, KO, please. Just come back.
One enemy remaining. Spike down A.
There they are. Shotgun.
This is good timing.
Capacity planning estimations. And so you should be prepared to identify also performance bottlenecks, maybe even proposing solutions in your distributed architecture. For example, adding a cache to lower latency. And so,
Oh yeah, cache. Always implement cache to lower the number of raids. Can have a hot cache.
I've linked down below an article that should cover everything that you need to know about performance optimization as well. Second to last, we have fault tolerance and redundancy. And so this is relatively basic. You should be able to recognize and communicate to your interviewer that
Go, go, go.
All 5. Oh, alright, cool.
failures are inevitable in distributed systems. And so you should be ready to discuss things like replication strategies and failure detection mechanisms. And your design should incorporate redundancy at the appropriate levels, servers, racks, maybe data centers, so that you can recover from these failures gracefully. Last up is capture. You're gonna talk about capture earlier in your interview, oftentimes the non-functional requirements, and you're gonna wanna make sure that your system upholds whatever decision you make as it pertains to cap theorem. And so cap theorem, of course, is consistency, availability, and partition tolerance.
Consistency, availability, and partition tolerance?
Your system, and so cap theorem, of course, is consistency, availability, and partition tolerance. Your system can only have 2 of the 3. Partition tolerance is a guarantee, and so your only decision is should my system prioritize availability or consistency?
Availability or consistency? Should the system be available or should the system be consistent? In a trading platform, it should be consistent.
And now, if this is foreign to you, you don't know what I'm talking about, don't stress it. We have a really detailed video on cap theorem as well. I think it's less than 10 minutes long. Should go quick, and that's also linked below. And then we have our database. And so this is where your data lives when the power goes off. You have options here. You got a traditional database like Postgres, which is going to keep everything organized in these strict little tables with clear and defined rules. You
Damn, our teammates are good. Let's go.
also have maybe relatively newer options like MongoDB is going to store information, more documents, and JSON blobs, and then you have other things like Redis, which is going to store simple key value pairs that you can look up really quickly. Now, importantly, and I see this mistake a lot, don't get caught up in the old SQL versus NoSQL debate. Most modern databases can scale well and can maintain data integrity. And so the real question isn't SQL versus NoSQL, it's how does your app need to read and write data? And then you should choose the option that makes those common operations fast.
That makes sense. Nowadays, all databases are fast, I guess. It comes down to like what is the best option for the data that you guys use. Like what's the most convenient? Okay, bro. You're so good at this game.
And simple for your use case. For your cache, you can think of this like a system of short-term memory. And so caches, Redis is a popular example, they store frequently accessed data so that you don't have to keep data in. Now they're way faster, but they do come with their own challenges, mainly around keeping data fresh. And so you need to decide, for example, how long information stays valid. When do you kick it out of the cache? The main thing to remember when you're choosing caches is that they're going to make your system lightning fast for repeated requests, but managing them adds.
Damn, our teammates are carrying. Love that. Love that. I feel like they go B this round.
Gotta go. Gotta go. Shortcut.
One enemy remaining. Spike down B.
I'm out of here.
Defenders win.
Suck it.
We were never here.
Some additional complexity to your design that you're going to want to be aware of. Message queues, how different parts of your system can talk to each other without having to wait around. And so instead of making direct calls, one service can drop a message into a queue. Popular ones are like Kafka, RabbitMQ, maybe
Kafka, RabbitMQ, Kafka, RabbitMQ.
SQS. And then another service can pick it up and process it when it's ready. And so you can think of this like texting instead of calling. You don't need both sides available at the same time. It can happen asynchronously. Now, this helps your system handle traffic spikes and it keeps things running, particularly if one service were to crash, for example. But the main challenge is making sure that message is actually delivered in the first place. And so sometimes they deliver once, sometimes potentially they deliver multiple times, and you're going to need strategies in order to handle this. You can think of load balancers as the traffic control for your system. And so load balancers take incoming requests and they direct them to different servers so that no single machine gets overwhelmed. So this server box here typically will horizontally scale it, meaning we'll need more than just one computer, we'll need multiple servers. And then the load balancer is going to be determining when a new request comes in, which of those servers it should route that request to. That simple. Your database is designed for organized, structured data, like user accounts or product information.
But things like
It's not designed for
images,
storing large files,
videos.
things like images or videos.
I
And so
literally just
trying
said
to
that.
cram those things into your database is like forcing a square peg into a round hole. It's going to bloat your database, and it's going to slow down all of your queries and make
I'm
backups.
some sort of a blob.
And so that's
storage.
why services like blob storage services, S3 being a popular example,
S3.
exist. They're specifically built to handle these types of unstructured data. This is typically media, large text files, etc. And they can host them at a much cheaper cost. And so always keep your structured data in your database and keep your unstructured data in your blob storage. Your CDN, or your content delivery network, it's just a cache. CDN confuses a lot of people, but it's just a
CDN is basically to allow people to access data basically on a more global scale. CDNs, which stands for Content Delivery Networks. So in some case, like somebody in Australia, we can host some CDNs over there, and that way they can fetch the data from that CDN instead of having to go through all the way to the US, which is a way higher, I guess, latency that you'd experience to grab that data.
the cache, it serves your global distribution system. And so you can place your content closer to users around the world. So popular CDNs are like Cloudflare is one, and they can store the copies of the images and the videos and other static files, oftentimes that you're hosting in bulk storage, but they're going to store them closer to the user. And so it's going to make it a lot faster for users to download these resources because they don't have to go all the way to, for example, America. If they're in India,
It's literally what I said. I know all this stuff.
they can just pull in these images and files directly from the CDN server in their native country. Okay, finally, the most important part. So if you're thinking that everything that I just talked about was not foreign to you, then you are already ready to start working through the problems, even if you weren't an expert on everything that we just described.
Okay, yeah, I think I just need to do more problems.
For anything that was maybe less clear, I've added a bunch of links below, as you know, and you can go either watch the videos or read the written resources in order to help close that gap. But in reality, most of your learning is going to come from working through core problems. And so I recommend that you work through these problems that you see on the screen here in this order, starting with Bitly and Dropbox Ticketmaster, and then all the way around until you end with post search. There's just 10 problems here, and they cover the overwhelming majority of concepts that you're going to see in a system design interview. And so with each one of these problems, you're going to be introduced to techniques and patterns that are going to continue to reappear.
Yeah, I just gotta download these videos in my brain, I feel like. And I'll it'll be good.
Gotta go.
Bar for bar.
I'm out of here. I'm out of here.
Bro.
Last
Spike
player
down.
standing.
It's over, bro.
Spike down mid. enemy remaining.
I got Spike.
30 seconds left.
I think I dinked him. Do you think I go B or A? I don't know.
Ten seconds left.
Spike planted. Almost ready.
Oh baby.
Almost
Oh
got
baby,
me.
baby.
Not.
How was I supposed
Not
to
a step
know?
wrong, Neil.
Here, in problems later on in the test, is going to help reaffirm these concepts to you. Now, Steph and I have written detailed breakdowns and recorded videos for each of these problems, as well as the videos. And so you have something to guide you throughout this.
Maybe I watch one problem a day 3 times. I think that's like a sure proof method. No?
Target sighted mid.
I'm out of here.
Left deployed. Target 86.
He just left.
Go, go, go.
We're so try-hard and sweaty. It's disgusting.
Almost out. Go, go, go. Right here. Drop in a smoke.
Just gotta flash out of that.
Adapt or die! I'm out of here.
Last player standing.
Smart move. Here we go.
One enemy remaining.
That's 3. Shocking.
Yo, I'm the best. I'm legit the best. Nobody should be messing with me. I'm legit the best.
Last round before the switch.
I'm a menace. Cannot be stopped.
Go, go. Go, go, go.
If for Bitly and Dropbox and maybe even Ticketmaster, you can start by just passively consuming the video. I think that's reasonable. But after those 3, the key, and this is so important, the key.
The key is to apply what you've learned.
Go, go. Get out of my way.
Joke's over. You're dead.
Enemy spotted B. Enemy spotted B. Our spike carrier's down.
Spike down B.
My ult is ready. I have this enemy spotted B.
Our spike's down.
Last player standing.
Never left.
Last player standing.
Lacking,
One
bro.
enemy
Please
remaining.
win this for me. Oh my god, he can leave, no?
I got the spike.
Yo, just leave. Yes! You're so bad. What the hell is that
Switching
emote?
sides.
Unpaid chatter.
I'm out of here.
That's true. None of my chatters are paid.
Key is to try it yourself. And to open an online whiteboard, start a timer, and work through the problem. At the end, you're gonna know
All
exactly.
right, I gotta watch Bitly, Dropbox, and Ticketmaster. That's gonna be my goals. I'm just gonna follow this guide because this guy knows what he's talking about. You know what I'm saying?
You were confused. These are what we call your known unknowns. And so you know about Google, you know about ChatGPT, and you can start searching and filling in those blanks that you have in your understanding. And then, and only then, should you fire up YouTube or open the website and watch the video or read the breakdown. And this is going to show you then all of the unknown unknowns, or the things that you didn't even know you were missing. And then rinse and repeat the cycle through all 10 of these questions. And I promise you that after doing so, you are going to have a really solid understanding of systems and concepts and feel really comfortable going into your interview. Now, if you happen to be a Hello interview,
Gotta go.
Enemy spotted A.
Spike down mid.
Oh, he's so lucky.
premium user. Then we make this cycle, we can hopefully kind of fun. So for each of these 25 problems, you can open up what we call guided practice. And you can work through problems in order in the delivery framework that we just showed. And then in each, for example, answering this deep dive question, we're going to analyze your whiteboard as well as whatever your text responses, and then give you
Wait, you can analyze what you wrote? Are you kidding me?
inline feedback to teach you concepts and help you improve as you go. So try guided practice. Ticketmaster is actually free to everybody, but for premium users, this is probably even a better way to handle that practice iteration.
No, I might pay for this, low key.
Yourself. So there you have it, folks. That is how I would prepare for system design interview today. You have all the links below. Go through them, especially the concepts that are less clear to you, and make sure you're practicing. The only last thing I would add, of course, is that system design interview is also about presentation. So make sure that you're actually audibly practicing, ideally with somebody else.
I know how to speak, I think, in a logical fashion, in a sophisticated manner. I would like to think so.
Maybe they're pacifists. Go, go, go!
Enemy spotted B. Reloading.
Spike planted.
Yeah, right, he hits that. Oh, no.
This could be friends, colleagues, coworkers, peer mock interviews. We at Hello Interview also have professional mock interviews where you can interview with an interviewer from your target company. So for
Oh my god, I'm leaking, What am I doing? I'm trolling. I'm leaking.
example, an interviewer who's active in your meta. Consider that. But I hope this was useful to you. Feel free to leave.
Go, go, go!
Why is Jake on? No shot he's on. Yo, just let me cook. Let me cook. Oh, wow.
Spike down mid.
Please, team. Please hold it down for me. What is so funny? I got my 3. Shut up. I gotta learn things.
Spike planted.
Joke's over. You're dead.
Last player standing.
lost and I got my 3 and my team got nothing. Love that. Oh. Oh. I needed to kill that Phoenix. God damn it.
Fight till the end, no matter what.
God damn it. That was in such a good spot too. No. Alright. Let's see. Let's see.
I'll show them. Lintik kayo.
Lintik kayo.
I'm out of here.
It's most definitely A.
Spike planted.
Damn. I just got shooted on. Are we actually gonna lose, team?
I have your back.
No, it was perfect. I mean, at least needed one. Ew! Shooting while we're running. Oh, it's over. GG. GG. Alright, at a high level, preparing for systems design is really assembling the right pieces. Practice common problems, delivery framework, key text, patterns, course concepts. Experienced candidates may just be organizing things you already know, ready for interviews. Maybe do some deep dives, learn about some relevant topics. You're really short on time. I still got a month. My team is ass. How do I carry that hard and still lose? Bunch of butt cheeks. Alright, interviews will be asked to design a system, design the backend for chat application. So that will be useful for product design. Infra are less common. Wait a minute. I'm getting an infrastructure question. God, what? I thought product design was less common. How do I play? Let's do all this stuff. Design a message broker or a rate limiter. Consensus algorithms. Oh my god, that is so cringe. Oh my god, bro. It's over. It's over for me. I really gotta design something like that. Let me look at that email again just to make sure that it's... Oh man. Oh, it's just gonna be systems design, I think. Yeah, I think I'm fine.
B.
Oh no, we.
Spike down B.
Team is on the way. It's over.
One enemy remaining.
It's not over. We're chilling. Good job, team. So it's systems design, but what is infrastructure design? I don't understand.
Spike planted.
The jig is up, team.
Last player.
Damn. Whatever. Let's try. Let's try, brother. So what am I? I'm not a product. Or ambiguously systems design. Hmm.
B.
Oh my god. Again. Team is on the way. Nice team. Good job, team. Good job, team.
Last round in the half.
No point saving. Buy it all.
I don't know. Do I study this stuff? I don't understand. Well, I mean, I guess I know what I'll... I could do some research. Maybe. Because it's not product design, though. But I don't know. It's confusing. can't hear anything, so I'm assuming they're both side. Dang you! Guys, fast as frick, boy. What is this, ADHD? I'm min-maxing, okay? Everyone relax. I'm min-maxing. Object-oriented design. I don't think we're doing this one. Front-end design, whatever. High-level design. I think it's LLD. Wait a minute.
No peeking. Gotta go.
Spike planted. No peeking.
Last player standing.
Okay. Min-maxing what? My time. I'm min-maxing my time. Alright? Something you wouldn't understand. I ain't gonna learn anything. What do you mean? I'm scoping out my roadmap, alright? Stop hating. Because you can't do what I do.
Go, go, go! I'm out of here!
I will hold up the sky.
Gotta go.
Go, go, go! We're good!
Yo, team! Do something, bro. I'm getting baited somehow. Oh, whatever.
Player standing. Spike down B.
One less.
Wait. Oh, what did I believe? Almost guaranteed. Okay, so I'm not getting a product.
Match point.
Fair winds, die corners. Time to show off, Jay.
It's only because you're bad at the game, Techno. If you're good at it, you will like it. Dude, why is there a wall there? Who puts a wall there?
Down A.
I can't hear anything, so I don't care. Alright. Let's see. Let's sort by new or popular. Or new? Design a system where you can only scrape only Wikipedia.
Defenders win.
Wait, we lost? GG. It's over for me. Fair enough. This is depressing, bro. Look what happens when I don't try. My teammates can never carry me. Is it infrastructure design though? Blue light filter debuff. It's more like not trying debuff. No music or no sound. Not locked in fully. The design interview is either what is this? What is this? What is this? Meta systems design versus product. Grok, is this streamer dumb? You're dumb. I spent 5 years, I figure.
Mark 2.
Oh, it's over. They did a 1-2, really? These guys are so try hard, bruh. Product design. The thing is, like, Meta has two options, which is systems design and product architectural design. And I guess the product design is more on API design, usability, and utility, but systems design is more focused on scalability, distributed systems, performance, and efficiency. So, to be honest, I think it's all the problems. Yeah, I think it's whatever. I think I'm overcomplicating it. It's not like anything new. It's probably like just design Facebook chat or something, design Uber, or design all these random services.
I'm out of here. Gotta go.
Gun here.
It's really over.
Taken out. Spike planted.
Show me a target.
You guys are so try hard and sweaty, bro. It's disgusting.
Reloading. No peeking. Last player standing. One enemy remaining.
He's 140, bro. Team is so useless.
Charge and shoot.
I have to do everything, man. Every time I have to do everything. Or else my team won't do anything.
Go, go, go.
Disgusting.
Time's up. Let's
I guess I see. So the questions can be the same, but the focus could be different. It's very interesting.
You had your fun. My turn.
This Sova is so sweaty.
Last player standing.
These guys are so freaking sweaty, bro.
One enemy remaining.
Ooh. He was there. Let's see. I mean, way to go back. Why that's planning is planning.
Spike planted.
Wait, he's looking nice right now. Love is looking nice.
My ult is ready. Do I get a prize for that or what?
Last round before the switch.
Spend everything. Hoarding money is reloading.
Design memcached. Design a message queue. Design, bro. What? Oh, pure infrastructure. Oh my god, bro. I don't know which one I'm supposed to study.
Gotta go.
No distraction.
Reloading.
I'll get his ass.
One enemy
I got his
remaining.
ass. Sit down, Sova.
A.
Sit down. Sit down, little boy.
Sweet dreams, asshole.
Switching sides.
Go, reloading. Nice. Killed it. And them. Gotta go. We definitely killed them.
These are questions you would not expect them to come in. That's the thing, though.
Do not relent. Marked one. Trying to hide.
Go, go, go.
I got the spike.
I'm out of here.
Time to go.
One enemy remaining.
Gotta go.
Cringy Sova. Get it, stupid. Get it, stupid. So the reality is that the questions can be the same. That said, there is one near guarantee. In a product, you'll be a user-facing product. On the other hand, questions that focus on pure infrastructure or back-end or system design questions you would not expect. Wait a minute, what?
Stay safe.
Oh, in a product architecture.
Enemy spotted. Go, go, go. Blocking sight. Shocking. Enemy spotted A. Dropping. They're dead. Gotta go, Nate.
Damn. Back Shite.
One enemy remaining.
He was like flank or something, huh? Oh, drop.
Spike down A.
Get his ass, ISO. Oh, don't do it.
Player
Ah!
standing.
Oh, yes.
Did I get inside
Oh
your
my
head?
god, I hate these people. Are they trying to style?
Match point.
Outside of this gig, immortality doesn't have
You know, if you
as
run
many
into the
basic
door,
benefits
if
as
you
you
like
think.
hold W and like D going into the door, you go like flying.
I've never tried it, but I know it's a thing.
Like that's the only reason I got past you.
Oh.
It's actually kind of fun. You go real
So
fast.
it's just W and D?
Yeah, yeah. So if I open the door, if you're on like the left side of the door, you just run WD into the door. That's what you.
Interesting.
Blocking sight. Enemy spotted.
Enemy spotted A.
Stay down. Multiple enemies A.
Yo, flank!
enemy
Yes.
You had your fun.
Yeah, wait.
My turn.
One enemy remaining.
Oh! Wait, he's looking clean though.
Attackers win.
Right?
Are you
Hold it.
are you grinding?
No, I just watched the video. You just like hold it there and just wait.
That's what you learned?
Yeah, it only took like 10 years.
Damn. I mean, it depends, but yeah, it's true.
I don't know. I think a lot of times I end up like moving when someone swings. So
Yeah, ideally you just like put it where you think how far they're gonna swing.
but I also might play this game a lot when I'm tired. Because I took
yeah.
off work this
Match
week
found.
I was like trying to like fix house stuff, and so I've been sleeping.
Oh, that's good. Yeah, you can't play this game with no sleep.
But I mean, I also like only got 3 hours of sleep last night, so I don't know. I drank my roommate brought in a latte machine, and then I drank a latte at like 5, and I was up till 5
AM?
Yeah, I was up till 5 in the morning.
Jesus.
No, I drank a latte at 5 p.m. and I was up till
Yeah.
5 a.m. And then I woke up again at like 10.
Jesus.
You don't drink coffee, right?
Nah, I'm anti-coffee.
Anti-coffee or anti-caffeine?
I guess I should say anti-caffeine, or try to stay away from it. Do you drink it a lot?
I drink coffee every day, yeah.
Dude, what happens if you don't drink it?
Okay, last looks.
Nothing.
You all look wonderful.
I just
Me,
feel
I
maybe
always
less
look good.
motivated in the morning.
Go, go, go!
Dude, I don't understand how people use the classic. I fucking hate it. I can never get a headshot.
Right click or left click?
Left clicks.
I mean, depends on the range, but I'd say mid range is like sometimes accurate.
You don't drink energy drinks then, right?
Nah.
Like, sometimes on the weekend, I just won't drink a coffee, but I think at this point, I kind of like how coffee tastes now because I put like milk and sugar, so I'd rather drink it in the morning. And it just makes me more motivated. Be mean.
Drop in a smoke.
Mid.
I'm out of here.
And where the fuck are they?
Drop in a smoke.
Damn.
Viper down.
I'm out of here.
Oh, okay, I guess.
Go, go, go!
Okay, I guess.
Gotta go.
He's going back mid.
I got your back.
Fence.
There's Ben.
One enemy
Yoru's
remaining.
down. Go, go, go!
What?
It's just beautifully played. It is just beautifully played.
If you are not doing well,
What are you
keep
even doing
trying.
daily sport?
You
You have,
must
like,
keep
battle
up
pass or something?
appearances.
Yeah, battle pass. Okay, I should just do the rich thing and just pay for it. So I don't have to sink so many hours into this dumb radio night.
Yeah, why? You're not playing, like, why bother?
It's true.
Gotta go.
Let's go, there's 3 of them mid.
Reloading.
Spike down B.
One more mid, so.
One enemy remaining.
I have a feeling he's gonna go this way. He's so predictable.
Last player
Oh
standing.
my god. But he's brain dead. GG.
You know what we should do? I'll tell you.
Here are the most commonly asked questions in meta. Wow.
They even like nerfed Neon's sliding a lot too. I think
Wait,
it's back to what it used
it
to
did?
be.
What do you mean?
You're not accurate. You're not fully accurate during the slide anymore.
Yeah, it's not, but it's still pretty accurate.
No peeking.
That's
Spike down A.
There. I'm out of here. Shortcut. I'm out of here.
One enemy remaining.
My ult's ready. Watch out.
Flawless. Last round in the half.
See the full
No
meta
point
tagged.
saving.
Oh
Buy
my
it all.
god, I should just do this. Wait. Yeah, I need to upgrade to premium? I might have to buy this low key. Buy it tomorrow maybe.
I'm out of here.
I might just low key buy the battle pass up until
Quick feet, quick trigger.
what I need. Save time and money. Actually, not save money, but
Get out of here.
that is just unfortunate, bro.
Last player standing.
Design an ad click aggregator.
Spike planted. Switching sides.
Chamber, let me borrow one of your guns, please. Ah, come on, man, please.
Okay, sure.
Oh, for sure this guy peeks, right?
About like 50% of the time, yeah.
Let's go.
He's there.
Reloading. Grenade. Enemy spotted B. Dropping smoke.
Go, go, go.
One enemy remaining.
Damn.
Okay.
Last player standing.
Running headshot.
Team Ace.
What the hell? You're lagging.
What the hell are you right click?
See, it does work.
They'll hit back. Or at least they
Just one
should.
to the head.
Nah, classic is broken. Half shield classic.
I like the ghost more, but I think I end up just taking like longer range fights more often.
No, that's fine.
Oh shit,
I
sorry.
mean, Ghost is
I
better
meant
in that
spike.
scenario.
Let's flush them out.
Where are you? Enemy spotted. Mark 3.
Gotta go.
Enemy B.
Damn.
One on site.
Spike planted.
One enemy remaining.
25 on
Last
me.
player standing.
What the fuck? Oh, my
I'm out of here. Shocking. Next.
What the heck?
Match point.
What the hell is he
It
thinking?
is so personal, no? You take a gun.
I don't know.
If I just waited, I would hear him drop.
Yeah, nah, I don't know.
Gotta go.
That was terrible. What is the systems design and review?
Stay focused.
Oh, God, I really gotta prepare for this.
Where
hit.
are you? Lost in a smoke.
First he overheats.
Satchel out. Lost in a smoke. Go, go, go.
Hell no, I'm not going there.
Yeah, no.
Flank!
Last player standing.
He doesn't even push this on me. Yo. What do you think of this new skin?
I kind of like the sound effect.
Thinking about buying it, but not sure.
I'm out of
I
here.
like the sound effect, but I don't know. I bought a new Guardian skin, but I'm happy for that.
Nice.
It's the old one. It sounds so strong though. It feels so good.
Yeah, the mage funk is nice, yeah.
Yeah.
Move.
I'll find you.
Dropping smokes.
Go, go, go.
I can't see anything. Heaven!
Last player standing.
Like I
Spike
never
down
left.
B. Last player standing.
GG. GG.
Fire in the hole. Piss.
Sudden death.
These new friends of ours are not too friendly.
Common problems, but like, I don't think I'm gonna be asked any of these though. I feel like I'm gonna be asked something from the meta tagged questions. I gotta see what people have said.
I'm out of here.
I'm lurking, I don't care.
Gotta go.
Hmm.
Let's make them dance.
I don't think I'm gonna be asked these common questions.
There.
Or just come A, it's so free, bro.
Or spikes down.
Spike down B.
Just come A, bro.
down mid. Last player standing.
It's over.
There's like 2 watching the bomb.
Go, go, go! My ult's ready! I got Spike.
"30 seconds left.
Clutch or kick?
Let's go, Kevin.
10 seconds left.
Going mid.
What the fuck is up there?
Defenders win.
It's impossible.
What the heck?
It's over. Let's see. How much do I have left? I have so much
Oh,
left.
baby, you rocked an 87 combat score.
What happened? What happened to you this game?
It's split. It's not.
It
in the
looked so
rotation.
good last
I don't know
game.
where I'm looking.
Conducting thousands. Okay, why don't I look on Reddit? Meta on-site. Interview experience. Product architecture. This is not what I'm going to be asked. Infrastructure. Infra reject. Okay. Systems design. Okay. I got a standard infra question from Hello Interview.
Match
The
found.
interviewer was not collaborative from the start. I was pushing the conversation about asking about requirements. I got sign off for both functional and non-functional, then moved on to data flow, discussed the steps. They asked questions about how to scale the DB and concurrency related problems I mentioned during partitioning and discuss hashing schemes. They said I'm close, and that's where we ended. Pretty much used the Hello Interview template, and I feel like I did meet the bar. Do ensure you solve the top 200 problems, and you should be good to go. 200? I've only done 50, bro. No. I can't do 200. It's over. Maybe I could do 100. I don't know. 100? Is 100 enough? Like, I can't do 200. Both of my questions on my second round were not off Leetcode. GG. That is so unlucky.
Viper, you must let me take you out sometime. Dinner, dancing. I know the perfect place.
Chamber, I would rather drink my own poison.
I'm out of here.
Nice, bro.
Toxin screen down. Spike planted.
500 Leetcode lifetime.
Toxins going up.
My system design was on
Toxin
crack.
screen down.
One enemy remaining.
Low level design of
Toxins
MapReduce.
going up.
Holy nerd. Jesus Christ.
Toxin screen down.
Last player standing.
Teleport's ready.
10 to 15 problems a day? Dude, how can you do 10 to 15 problems a day? These guys are built different, man.
That Raider won't touch a soul. I'll make sure of it.
Maybe if I got off the game and grinded. Dude, I think I don't know. Dude, it's like I'm not even like trying to study slow. Like I feel like the process takes time to study, and like I feel like I'm going at a reasonable pace. Well done, well done.
One down.
Damn.
Take a shot playing though.
One enemy remaining. Last player standing.
You had it coming.
He's out of bullets, baby.
Time to kneel.
I don't know. I went through only 2 questions today, but like, oh, I don't know, dude. It took me hours to get through that one question. I guess I just have to go through them faster, maybe? I feel like I still haven't seen all the patterns yet. I don't know. I feel like I legit just see like new patterns all the time. I don't know. Maybe I should still look at the answers more quickly. Maybe I'm taking too long to try to figure out something. I don't know. I don't know, dude.
I'm out of here. My ult's ready. I'm out of here.
Get styled on, boy. I'm 1 HP.
Don't get in my way. Spike planted.
One mid.
Here.
Last player standing.
75 on Viper.
One enemy remaining.
He's low.
Toxin screen down. If you
Mm.
want something done right, do it yourself.
Last round before the switch.
What is ND or NC?
Pack heavy.
Nice. Maybe.
Gotta go.
I discussed multiple solutions. Ultra strong hire. Ultra strong hire. Yeah, this guy
If it is
killed
Kobe.
it.
Quick feet, quick three. Go, go, go.
Oh, okay.
Get out of my way.
missed. It's on the fucking ceiling.
The hell was that? Wait.
I'm out of here.
Beacon BBB.
The hunt begins.
Oh no, they're both spawned.
Spike planted.
What the hell is a map reduce? I have no idea what this stuff even means.
One enemy remaining. Last player standing.
What are you doing? Why are you trolling?
Clutch.
This filter is getting to me.
Switching sides.
It's playing with his food.
Okay, be flicked. Be flicked so quickly.
Should be my last one, I think. Rather than memorizing the top 100 questions with pure perfection and solving these questions perfectly, become better at showing the review the signals. And what happened?
I said I have no clue where to put this wall. I'm just gonna
Oh,
use it for
usually I
retake.
think it's like that, something like that. But you can use it for retake.
Oh, why would that be?
Viper all be.
Damn.
Enemy down.
Rather than memorizing the top 100 questions with pure perfection and solving these questions
Spike
perfectly,
down,
become
B.
better at showing the interviewer's signal.
One enemy remaining.
5 minutes. Clarify requirements, edge cases, ambiguity in problem wording, structure, size of inputs, outputs. This alone can be 10, 12 questions. 5 minutes. Think of as many solutions as possible. Compare and contrast time and complexity. Prove the optimal solution.
Please stay alive.
5 minutes.
hate
Code
making new
whatever
friends.
solution you want, depending on your justification for the trade-offs.
Defenders win.
What the hell?
Unwinnable in a swift play.
It doesn't have to be perfect. 5 minutes. Dry run. Catch 90 mistakes of the mistake. Yeah, you don't. I guess you don't have to code 100% correct. I know I'm not a perfect coder when I can't run code, so I relied on the dry runs to perfect my code. This is a massive positive signal to meta interviewers. The reality is you should be able to solve unseen questions in 10 minutes. That's true. I shouldn't depend on luck. I guess I should just keep solving problems. Alright, last one.
Alright. Yeah,
I
sounds
bet.
good.
Are you still studying?
Yeah, I mean, I do like not that many problems a day.
Match
I feel like I do
found.
like 2 or 3, or like I'll review an entire, like. How many are you grinding out a day?
I guess as many as I can. But some questions, like today, I got like stuck on it for like an hour, like couple hours. Actually, like couple days, low key. But I feel like 2 to 3 a day is like, it's good for like long term.
Yeah, I mean, I kind of was just doing it for, like, I guess supplemental stuff, and I was just kind of curious because people said like everyone was doing it, and I guess it wouldn't hurt if I'm trying to like change jobs at some point.
Yeah.
But oh
Definitely
my
get
God,
paid
every
more.
time I'm just like, fuck, man. I have no clue how to even start this problem other than brute force. How the fuck do you not do this problem in a brute force?
I feel like, wait, how many questions have you done? Like total?
I don't know, like 30. 40.
Dude, you have to just look at the answers in the beginning. There's no way. You don't know anything.
Yeah, I'm just like, I've seen something similar. And I'll look and be
Choose
like,
your
okay, that was
agent.
not similar at all.
Nah, sometimes it's just hella different. I'll just play Jet, I guess. Can I play Fade? Yeah, I'll just play Fade.
Everyone is afraid of something.
Yeah, I mean, I still feel like the same way. It's just like, how the hell are you supposed to figure that out? I got multiple questions that were not directly code problems.
We're gonna kill it. And by it, I mean those bombs over there.
I guess so. If I went faster, I wouldn't have to spend... I could do more questions, but that's the thing. I don't know if I can go faster.
Smoke C. Yeah, C.
Spike down, C.
Okay.
Last player standing.
Paige, how long are we going to
Spike planted.
walk this flank? Alright, GG. Did you take any vacation? Spend 4 hours after work. I picked questions, 3 to 4 problems, not a terrible pace, but you have to stat focused. I did some competitive math in high school. Oh my god. So, yeah, he has long-term exposure. It's not fair. Yeah, 10 to 15 problems a day is crazy.
That was so weird. I got smoke plat.
Nah, that's weird.
I've never seen anyone smoke plat before. Like back here, like this.
That's built different. Mid.
Smoke C again.
Gotta go. Target spotted C. Target spotted C.
Turn 138.
Spike planted. Last player standing.
What is happening, bro? The Sage is baiting like usual.
I don't think he's baiting. I think he's just bad.
No, it's both.
Make their
He's baiting
fear
because
your
he's
weapon.
bad.
Or use a gun. Whichever.
Yeah,
Go, go, go.
Alright, I'm gonna fucking wall off garage.
Progress is not linear, yeah. Seems like you need help there.
Yes, please. People are just fucking running on. Oh, you gonna push this?
I want to eye something, but I don't know.
Just save it for when they smoke.
Where are you?
Oh, it's C. Oh, it's C.
Throwing net. Glory kill.
Spike down, C.
Human kill.
One enemy remaining.
Yes, yes, yes. Guy's lurking.
He's probably sitting outside that smoke garage.
He's C.
Last round in the half.
Reservoir sampling K elements from stream of data. Vertical order traversal of a tree. Add decimal strings given a bunch of strings. Accounts merge some LCA variant. Good night, Moku. Take care, take care.
I'll find you.
Prepare for hellfire!
Enemy and attacker spawn.
Reloading. My ult is ready.
Spike down. C.
We're good. Shock it.
Spike spotted C.
Enemy C.
I'm so ass. Wait. Are you still alive?
I don't know.
Well, if they're smart, they leave.
Oh, these bitches.
I mean, what did you expect?
I didn't realize women had ult, I'll be honest. I was wondering what they were doing.
Actually, didn't even know you had bomb. Nice. Ooh.
My grenade threw me off.
Switching sides.
Hi.
Fight's not over, you know.
But 4 hours of studying is probably the biggest lie I've seen on this thread. Yo. Oh my god. That's how I feel. But like, yo, people are built different. And it's like, I gotta get to that level, I guess. Yo, competitive programming is legit like unfair. If you're good at like, if you're just competitive programmer, then you're just set for life, low key. It's kind of stupid, but I guess it is what it is.
Gotta go.
Bring them down.
I'm out of here.
Throwing next. Clean kill. Reloading. I'll find you. Mark one. Gecko down.
Oh, look at that scam, baby.
Reloading.
One enemy remaining.
Damn.
You're
I
strongest,
just baited
not
you.
enough.
Oh, that was yeah, that's you.
Neutralize the enemy gecko.
I was like, oh man, that was food.
Go, go.
This is taking your shit.
Gotta go.
You did good though. You held it down. I mean, I had your trade.
Oh yeah.
Yeah.
Didn't know you were there. Dude, why do these people keep just grabbing the net
I'm out of here. Through
right
the
next to them?
storm, I fight.
Go, go, go.
He's panicking. Oh my god.
Many enemies A.
Healing you. Bring them down. Throwing net.
I'm just so ass at this game.
Kill confirmed. Ultimate ready.
What is everyone here?
Go through meta loops where we only got questions from their Leetcode tag list. 50 problems done in a month was enough. What?
Oh, you got killed by the save.
Headshot.
Yeah, I'm not doing that.
You're scanning solutions and copying code at that point. I think you're underestimating how good Guardians on Leetcode are. I know high schoolers who are better than this. This comment up above is the definition of coping.
Last player standing.
But we're talking about a very small population. That is true. 500 is more than enough. I agree. I think 500 is way more than enough.
30 seconds
'Cause
left.
I don't think I've even done 200, and I feel like I'm starting to get to that point.
Sensor
I
tripped.
retracted my statement. It's for sure possible, but I still think very few people can do it. I agree.
No escape.
10 seconds left. One enemy remaining.
How the fuck did it take my bomb out? Why did it take the gun out?
Match point.
Let's try.
Get ready. I go fast.
Why am I in the center? I guess because I was leak coding and then I was blocking the question. I put myself in the center. Maybe the center. I don't know. I think it's better for studying. But for Valorant, I don't think so. But whatever. It's fine.
Their fears betrayed them.
It's predictable. They're gonna stack C.
I'm out of here. Where are you? Shortcut. Bring them down. No escape. No peeking. Barrier, no peeking. We'll catch them. Spike planted. Barrier closed.
I'm so bad. This is GG.
Last player standing.
Message
Wait.
sent.
Oh. GG. Alright, well. Guess that's the end.
Defenders win.
You finished all your dailies?
Oh yeah, I've been done.
Oh.
I'm just trying to catch up though, because I haven't been playing. So I'm behind.
How much is it to buy XP?
Actually, maybe I should just buy it at this point. But I can't buy the last part. It's 1,500. So if I pay 1,500, I still gotta play. Actually, yeah, maybe the weeklies will do it. Not sure.
14 days? I guess you don't really have that much time, considering you're studying most of the day.
Yeah, I don't want to be playing that much too. Just pay for it. Damn, I'm like halfway towards 46 though. It's a waste, I think.
Just give your account to someone to play.
Give my account to someone. For free? I don't know. Actually, do I even care about... I don't even care about the Viper card. Also, the buddy's not that great. I'll probably just get the Radiant and not do the last one, maybe. If I don't have to.
What do you get the battle pass? Just for like the Radiant Knight?
Yeah. But I guess I could just buy it.
Oh, you can buy Radiant Knight now?
Oh, you could always buy it. It's just way more expensive. You get 50, 60, 70, 80, 90, 100, 110. Yeah, I think you get like 160, about 160 Radiant for Battle Pass. But then that's like that's like $100 worth, I feel like.
Right, that's actually a lot with that.
That's what I'm saying. That's why I just buy the Battle Passes.
I don't get enough skins to ever use up all my Radiant.
That's true. I am also at XS. I have 255 right now. Maybe I should. I don't know if I should buy the new bundle though.
I mean, if you like skins, whatever. Money is money.
True, it's true. I don't know.
I don't know if you invest, but...
Oh, I invest.
Do you buy stocks and stuff?
Did you get on Figma or no?
Did I get what?
Did you get in Figma?
Figma?
Yeah, it like IPO'd recently.
No.
It tanked.
didn't buy it on
Wait,
Figma.
what are you invested in?
Most of my shit's been in NVIDIA for a while.
Nvidia? Okay, I mean Nvidia's good.
Yeah.
You have a lot?
But I was gonna say, what brokerage do you use?
I use TradeStation and Robinhood, but TradeStation my brother just told me about.
I don't know if you would just want to like take advantage of it because, and my roommate just told me about this, so I transferred over some money. But, have you heard of Tasty Trade?
Tasty Trade? No.
Yeah, they did. Oh fuck, where are they? They were. I forgot that if I tab out, you can't hear me.
Oh yeah, I can't.
Tasty Trade was E-Trade or I forget what the old. Wait, can you hear me? Wait,
I can hear you, yeah.
Yeah. So Tasty Trade is a brokerage. They have a promotion going on right now.
What's the deal?
You just have to transfer over X amount of funds. You have to keep it for a year, and you get X amount of money.
Yeah, but how much?
I'll send you.
I'm not gonna do it if it's like
250K is 3K.
250K is 3K.
And then there's like other ones, but that's the one.
Is that the highest tier?
No, you could do more. Let me look at it real quick.
Damn, you got 250K at least?
Yeah, most of it's from Nvidia.
Damn, bro. Wait, how much did you invest in that?
I put in like, I don't know, but I have like 1,000 shares at like $18 each.
1,000? Wait, hold on. Let me see how many I have.
Because they split the stock. Damn.
I know. I mean, I got it at 12.45. I only have 360. You have 1,000? God damn. Wait, so 1,000 is. Damn. So you put like 18K? Holy frick. Damn, you got big balls.
Yeah, I just never sell because I was too lazy to do like taxes for it.
I mean, Nvidia is not going anywhere, so.
Hope not.
Dang, that's good though. So Nvidia is really like your only main play?
It's like half my portfolio, yeah.
Damn. That's good.
Yeah, so I sent you something, and then I guess if you decide, there's also like a promo code.
Is the app actually good though?
There's a referral code that if you make.
Wait, what? Can't hear you.
I sent you something on Discord.
Yeah, but you said wait, but is the app actually good though?
I haven't used the app. I just transferred money just to keep it there. To take.
No, I mean.
Take a.
You've never even used it?
My roommate uses it, but no, I just found out about this recently. I think this one was E-Trade, I think, and then they split off and made their own.
I mean, low key though, if you're gonna just sit, if you're not even gonna use that, and all you're gonna get is 3K out of it, that's like low key trash, no? You can make way more money with that.
It's kind of like free money unless you're
Well,
planning to like actively trade.
It's opportunity cost. 3K of 250K is peanuts. I don't even think that's not even 5%, is it? That's trash. You'd make more money just putting in the S&P.
But wait, it's already, well, this isn't, you don't have to put like the cash. I transferred over stocks.
Oh wait, you just transfer the stocks?
Yeah. No, this
so you don't have to sell?
I just transferred my Robinhood portfolio to Tasty Trade.
Oh, wait, so you don't have to sell.
Still buy on Robinhood and stuff, but like the only catch is you have to keep it here for 12 months.
What does that mean? You can't sell the stock?
No, you can't just transfer out. I think if you transfer maybe below the deposit amount out of it, then you might not get the tier bonus. You might get the lower one. Right?
When does this promo end?
I think maybe the end of the month or something. It says at the bottom.
Frick. All right, I'll take a look. Let's see.
Yeah, August 31st. You just need to use a referral code, my new bonus. And then I think there's another referral code I can give you. I don't know if you get anything for that one. That one, I might just get something for it.
We'll see. We'll see.
But yeah, this is what my roommate was telling me about. So I was like, oh, I guess I'll take advantage of it.
If you can still actively trade with it, then it's worth it for sure.
Oh yeah, so the people who made this were the ones who made TD Ameritrade. That's what it was.
Okay. I'm assuming it's good then.
Yeah, I mean, but do your own research. There's
Yeah. I'll check it out. We'll see.
Yeah, I'm pretty sure you can actively trade stuff, but I don't know. I didn't really look into it because I just kind of like buy and hold. So I'm not. I don't think I'm.
I mean, I'm not that
a
active
winning
either.
trader, so I didn't bother.
Yeah, I mean, I'm not that active either, but if that money has to sit and I can't, like, you know, do something else for a whole year, then it could be bad. Or not worth it, I guess.
So it says here, if my account drops below the funding requirement, will I become ineligible? Principal fluctuations due to trading will not affect your whatever, to keep your awarded cash value. As long as you keep your original 2K deposit in your account, then you'll be able to keep your awarded cash.
All right. I think I'm call it, yeah. Peace. Good night. All right, chat. I mean, I'm gonna wind down, but I'm gonna just research a little bit. I think I'm gonna just end stream though. Chat, I'm gonna end stream. I'll see you guys next time. Maybe tomorrow. I will try to study again tomorrow. So, catch you guys later. Peace.